Hello security gurus, welcome to AWS DevSecOps course where we are going to implement DevSecOps pipelines within AWS, and also we are going to learn about implementing security services within AWS. I'm your trainer Guru from a security guru, and I'm going to take you through this journey. So let's jump into the agenda of the course. So first we are going to learn who is the target audience for the course, what are the course benefits, how it's going to help you to become a DevSecOps engineer. So it's going to be really interesting. Then we are going to understand what is DevSecOps, how this term came into existence, why shall we learn this term, and how it's going to help you to take your career to the next level. Then we are going to learn the tools that we use for DevSecOps. We will understand all the tools being used in an enterprise environment, and we will learn what are those tools benefits. Once we are good with the tools, we will understand the basic security terms that we should know before we jump into the implementation of DevSecOps. Once we are good with the basics, we will learn about the tools that AWS provides for implementing DevSecOps. So AWS has few native services that we will be using for implementing DevSecOps. Then we need to create an AWS account. We will go through the steps. It's going to be a hands-on journey now from this lecture onwards, where we will start implementing everything within AWS. Once we have the account created, we need to install Git Bash. If you are not aware what is Git Bash is a tool for working with your source code. We will install it on our Windows machine, and then we are going to connect our Git Bash with the AWS code commit. AWS code commit is very similar to GitHub. It's just that AWS code commit is a private repository. We are going to connect Git Bash with AWS code commit so that we can push vulnerable application to code commit using Git Bash. As soon as we have an application ready for implementing DevSecOps, we will start implementing the build spec YAML file. This file will help us to create a build pipeline or DevSecOps pipeline within AWS. Once we have this pipeline ready, we will start creating a Sonar Cloud account. Once we have the Sonar Cloud account created, we will integrate Sonar Cloud with our build spec YAML file so that we can create a secure pipeline within AWS, and thus moving towards a journey of implementing DevSecOps within AWS. Next, we will populate the code coverage within Sonar Cloud. This is going to be a very important lecture as this is a real life scenario. I have experienced this issue while working on a live project. I'll explain how to fix this issue. Being a DevSecOps engineer, we need to know all these things. Then once we are good with the Sonar Cloud, we have integrated static application security testing within our DevSecOps pipeline. We will move our security tokens from our YAML file to the AWS secrets manager so that our pipeline is secure and there is no confidential information present in our pipeline. Once our pipeline has been optimized and there is no confidential information being stored in pipeline, rather we are fetching it from AWS Secrets Manager, then we will implement quality gates for Sonar Cloud within our DevSecOps pipeline. This will help us to fail our build in case our security gate is failing as well. This is very important as well. Being a DevSecOps engineer, we need to have these kinds of quality checks on the source code. Once we have done it, we will move towards implementing software composition analysis step within our AWS DevSecOps pipeline. Till now, we would have integrated static application security testing and software composition analysis within our pipeline. Next, we are going to learn about cloud security posture management. It's a new topic, very hot in the market today. Nowadays, implementing security within cloud environment is becoming automated, where we run the automated tools that scans our infrastructure to identify any kind of configuration issues. We are going to implement this tool within our AWS infrastructure to identify configuration issues. It's going to be a very interesting implementation, and you will see what kind of issues are identified that you should know being a security engineer or DevSecOps engineer, and what actions you need to take against those issues. Then once we are good with implementing CSPM, we will start implementing native AWS security services. We need to be familiar with all these services because while working on a live environment, you will be given the task of implementing these security services within AWS. It's going to be very helpful. After that, we are going to learn how we can utilize this information, and we can start putting this information that we have learned within our CV so that we can apply for DevSecOps jobs. I will help you to create a DevSecOps engineer CV, and also I will explain some of the other resources that we are providing to you at a discounted rate. I'll also explain what are the other careers within security that you can look into as per your interest, and what are the new careers that are being introduced within security. So it's going to be a very interesting course. It's going to be a hands-on course. I just need your commitment towards implementing each and every tool that we are going to integrate within our CI/CD pipeline, and you will be ready to implement DevSecOps pipeline within AWS in an enterprise environment. I hope you are really looking forward towards this journey. You are as excited as I am. So let's jump into the action and see you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to understand why should you learn this course and who is the target audience for this course. So first, let's see the target audience for this course. This course is designed specifically to introduce freshers, security engineers, QA engineers to the field of DevSecOps. Since DevSecOps is a very new field and there is a huge demand within this field, we want to help IT professionals and anyone who is working in the field of information security to jump into this field. Let's understand why we want professionals to learn the field of DevSecOps. The reason is that DevSecOps is a very niche domain and there is a lot of demand in this field, and very high paying jobs remain vacant because of unavailability of the right talent. We want to create the right talent for the market so that we can fill this gap that is present in the market for DevSecOps field. We want to help engineers to learn DevSecOps so that they are able to grab higher salaries for their job and they can upskill themselves in the latest technology trends. So I hope you have understood why we have created this course and why you should learn this course and should not miss the opportunity. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to learn about the various security terms that we are going to use throughout the course. So let's see what are those terms. The first term is SAST, which stands for Static Application Security Testing. This is a white box testing that analyzes the source code for identifying security issues within our source code. Now we can perform SAST manually, or we can use automated tools to perform SAST testing. For performing manual inspection of the source code, we can use a source code checklist and we can identify the security issues. But to perform the automated testing, we can use 45 Veracode and SonarQube to perform the automated scan on our source code that will help us to identify the security issues. Next term that we are going to learn is software composition analysis, which is also called SCA. SCA scans help us to identify which third-party libraries are we using within our source code, what kind of license issues might be associated with that library, and what are the security issues present in those libraries. So this is very helpful. It can be performed using tools like Snake, which helps us to automatically run the software composition analysis on our source code. Next is DAST, which stands for Dynamic Application Security Testing. We perform this black box testing on web applications as well as mobile applications using automated tools like Burp, OS Zap, which is an open source tool, Veracode DAST, Web Inspect. These tools help us to identify security issues in the web applications using DAST. Next is IAST, which stands for Interactive Application Security Testing. This is a fairly new term and it's a mix of both SAST as well as DAST. It tries to overcome the limitations that were present in SAST and DAST. It scans for specific workflows within the code to identify the security issues. Next term is also fairly new, which is Infrastructure as Code, or IAC. IAC is the process of creating infrastructure using code files. For an example, we can use CloudFormation templates to create infrastructure within AWS. Also, we can use Terraform to create infrastructure within Azure as well as AWS. To identify the security issues within these code files of Terraform as well as CloudFormation templates, we call it as IAC security testing. Next term that we are going to learn is API security. API security is the process of identifying security issues within the APIs. This security service is also called as security for microservices. We need to understand what is the difference between API and microservice. So microservice is a subset of an API. For an example, if we have an e-commerce application that has a user registration API, then that API will have microservices to create, delete, and update users. So this is the difference between a microservice and an API. So I hope you now understand the various security terms that we are going to use throughout the course, and you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to learn what is DevSecOps. So let's see. DevSecOps is made up of three terms, which are development, security, operations. Security is at the core of the term. That's why DevSecOps came into picture. In the past, software development lifecycle did not put enough emphasis on the security. That's why DevSecOps came into picture. So let's see what we do in the development stage. In the development stage, we implement security at the very early stage of the software development lifecycle. We start implementing security at the implementation phase itself. We implement security tools that identify security issues within the source code, and we also work with the developers to define secure coding checklist. Then, since we are implementing security at the very early stage of the software development lifecycle, that's why this process is called shift left approach, and its main goal is to identify security issues as early as possible, and in order to avoid any kind of security issues being identified in production. Also, we implement security at the operations level. For an example, if we are setting up a container registry, we make sure that only the secure containers are submitted to that container registry, and any kind of security issues that might be present in the existing containers, those are also identified. Also, if we are managing any kind of infrastructure, we implement automated compliance scans. We make sure that any kind of framework or standard that we are following is implemented across the infrastructure. For an example, if we are working on a credit card application, we would like to make sure that PCI DSS standard is implemented across the infrastructure, and we will implement some automation tools that will make sure that PCI DSS standards are followed. So that is what DevSecOps is all about. I hope you are now clear with what DevSecOps is. In the next lecture, we are going to learn about the various tools that we use within DevSecOps. So thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to learn about the various tools that we use for implementing DevSecOps at an enterprise level. So let's understand those tools. The tools that we use at the development stage, where the developers start writing the code itself, are Git secrets. Git secrets is used to identify any kind of security credentials or personal tokens that have been committed in the source code by mistake. Git secrets will scan our entire code repository and then will give a warning about any kind of such security credentials within our source code, and it will inform the developers that these credentials have been committed by mistake. Developers can then remove those credentials, and it will help us to avoid any kind of security credentials that might be committed in the source code by mistake. Next is security plugins that we can install within the integrated development environment. Integrated development environments are Visual Studio Code, IntelliJ, Eclipse that are used by the developers to write code. Now, many security organizations like 45, Veracode, SonarQube, Snake have released their security plugins for these integrated development environments. These organizations have released plugins for Visual Studio Code, IntelliJ, Eclipse. Developers can install those plugins and then identify any kind of security issues within the source code. This is called shift left approach, because with these plugins we can identify security security issues quite early within the software development lifecycle. The next tool that we use is Trufflehog. Trufflehog is very similar to Git Secrets, but it has enterprise license as well, so that's why I have listed here. Now let's see what other security tools are used within the build pipelines. So first tool is code quality tool, which is SonarQube. SonarQube is by far the most widely used code quality tool across the organizations. I have seen 90% of the organizations using SonarQube to identify security and code quality issues within the source code. Next is SAST security tools, which are Fortify, Veracode and Checkmarks. There are other static application security testing tools as well, but I have listed the most widely used tools. The next one is software composition analysis security tools. These are also Fortify, Veracode, Black Duck and then Snake. Next is dynamic application security testing tools, which are OWASP, ZAP, WebInspect, Veracode DAST, Akinetics. Then we have infrastructure as code security tools, which are Bridgecrew and Snake. Infrastructure as code is now widely used because on the cloud, most of the infrastructure is being created by writing code. That's why these tools help us to identify any kind of config issues within that code. Next is container security tools. We have many popular container security tools which identify security issues within our containers. These security tools are Aqua, Qualys, Prisma Cloud. Now let's see the tools that are used within operations. So within operations, we try to build the DevSecOps pipeline, and for that we need some build pipeline tools that can help us to create those pipeline, define all the steps that we need to run those pipelines. So those pipeline tools are Jenkins, AWS, GCP Cloud Build, Azure DevOps, GitHub Actions, and then GitLab. Next is cloud security posture management tools. These tools are now very popular because most of the organizations are moving their applications to cloud. That's why we need to identify any kind of configuration issues within the entire cloud infrastructure, and for that we can use Aqua, Bridgecrew tools. These help us to identify any kind of configuration issues. These also implement standards across the cloud infrastructure, and based on those standards, it will tell us which tests are failing across the infrastructure. Now next one is container registry scanning tools. As we put our containers within the container registries like Docker Hub, AWS Container Registry, Azure Container Registry, we need to have some security tools to identify security issues within the containers that have been placed within the container registries. So for that we use Aqua, AWS Native Registry scanning. Then we have infrastructure scanning tool. For infrastructure scanning, we use Chef Inspect, that is from the compliance perspective, and we have Nessus from Tenable, that is also widely used tool. Next is cloud security tools. For identifying security issues across the cloud, we use native cloud tools as well, which are AWS Security Hub, Azure Defender. These are security tools provided by these organizations as their native security tools, and these tools help us to implement security within the cloud. I hope you have enjoyed this lecture and have got the information about the tools that are used for implementing DevSecOps within an enterprise environment. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to the next chapter. In this chapter, we are going to learn how to implement DevSecOps in AWS Cloud. Now, AWS provides few of the tools for implementing DevSecOps, which I have highlighted here. There are other tools as well, but these are the most prominent tools that we need to be aware about. So starting with the first tool, which is AWS Code Commit. AWS Code Commit is a service provided by AWS for hosting our repositories or code repositories. This is very similar to GitHub as well, but AWS Code Commit is the native service provided by AWS for hosting our code repositories. So that's why I have highlighted GitHub here as well, just to show you a comparison of the service. Once we host our repo within AWS Code Commit, the code will be pushed to code build. Now the AWS code build will try to build our code. It can be a Maven application, it can be a .NET application, it can be a Java application, it can be a Node.js application. AWS code build will try to build our code, will try to run the unit test, and then will produce a software package. All of our security tools will be integrated with AWS code build like Fortify, SonarQube, Sonar Cloud, Veracode. All these tools will be integrated with the code build using a YAML file. We will learn all those things in the upcoming lectures where we will write a simple YAML file. We will also try to understand how we can create a YAML file and integrate security tools within that YAML file. Then we will move towards AWS Code Pipeline. AWS Code Pipeline is an end-to-end pipeline creation service provided by AWS, in which we can create our package, build our package, then deploy our package. We can integrate our public or private repositories from GitHub with code build as well. For that also we would need a YAML file to trigger builds on code build. We will see both these options from triggering a build from code commit and also triggering a build from GitHub. And also we will start integrating DevSecOps within AWS. So see you in the next chapter. Thank you. Hello security gurus, welcome to this new lecture. In this lecture, we are going to see how to create a free AWS account. I will post that link in the description as well. So let's start this tutorial. So first I'm on google.com. I'll search for create a free AWS account and hit enter. Then I'll go to this first link, aws.amazon.com. I'll open this link and you can see there is a link, create a free account. I'll click on this link. Once we click on this link, AWS will ask for root user email address. Since I've already registered a security guru email on AWS, I will enter a test email just for your reference. So I'll enter test@gmail.com and we need to provide AWS account name. So I have already given AWS account name as a security guru in my other account. So I'll put it as something for your reference. So test security guru, and then we will have to verify this email. Since this is a dummy email, I would not have the verification code with me. What will happen is you will have to enter the verification code and then you click on verify. Then AWS will take you to a page where you will have to enter your information like phone number, address, and then it will take you to a credit card page where you will have to put a credit card, where AWS will charge you 2 rupees to create that account, and then your account will be created. So once you create that account, your account would look something like this. So this is my AWS free tier account which I have created. As you can see, a security guru, I have already created that account, and you will be able to see this dashboard. Also, once you verify your email ID, AWS will ask you to set up a password and you will be able to log in to this dashboard using that email and password. Once you are able to create your account, we will start with setting up DevSecOps within AWS. So see you in the next chapter. Thank you. Hello security gurus, welcome to our new lecture. In this lecture, we are going to install Git Bash on our local system. We will need Git Bash in order to clone our repo, to make any new commits to our repo, and to push our local changes. So let's jump into the action. We are on google.com and we will type git space bash and download and then hit enter. So this is the link from which we will download Git Bash. Link is git-scm.com downloads. Let's click on it. Once we click on it, you will see that it will detect on which operating system you are working on. And since I'm working on Windows, I'll click on this to download Git Bash. We can also download it for Linux and Mac operating system. As you can see, it has already started downloading Git Bash on our local system. Let's wait for a few seconds for download to complete. As you can see, download has been completed. I'll double click on it. As you can see, Git installer has been opened. I'll click on next. Then it is installing Git Bash under C drive, program files and Git. I'll keep the same installation location and I'll click on next. As you can see, I want to have an an additional icon on the desktop. I'll select this option. Rest of the options I'll leave it as is and I'll click on next. Here it will create a start menu folder with the name of Git. I'll keep the menu folder name as is and I'll click on next. So it is asking that use Vim as the Git's default editor. So Vim is a editor which is used to edit any kind of files. It's very popular with Linux. So I'll keep it as is and I'll click on next. So here Git says that by default its default branch name is master. If we want to keep the default branch name as develop or main, we can select this other option, which is override the default branch name for new repos. But I do not want to change this behavior. So I'll keep the default option and I'll click on next. Then it says that there are three options, that either we can use Git commands from only Git bash, or we can use Git from command line as well as from third-party software, and there is third option using which we can use Git commands and some optional Unix tools from command prompt or Windows CMD. I'll choose the default option, which is also the recommended option, and I'll click on next. So here, as you can see, Git bash has bundled OpenSSH. SSH stands for secure shell, and we will keep the default option. So I'll click on next. Then I'll use the OpenSSL library. OpenSSL library is also very helpful in case we want to generate any kind of self-signed certificate. So I'll use the OpenSSL library and I'll click on next. Then it is asking us about the style or the user interface of Git bash. So I'll select the default option and I'll click on next. Then I'll choose the default terminal of MSYS and I'll click on next. Then it is asking us what do we want with the git pull option. So one is the default option, which means that whenever we will do a git pull, it will merge the changes coming from the remote branch to our local branch. Second is rebase. It means that if we do a git pull, rebase option will be done. So git rebase is done to put changes of one branch on the top of another branch. And third option is only ever fast forward. So I'll keep the default behavior and I'll click on next. Then we will be using Git credential manager. In the next lecture, we will have to set up credentials so that we can communicate from Git bash to GitHub. So our username and password token will be stored by Git credential manager. I'll keep the default option and I'll click on next. So here it will be enabling file system caching. That is fine. I'll click on next. So these are new experimental options which have been given to us. I would not install any of these options. So I'll click on install. As you can see, it has already started installing Git bash on our local system. Let's wait for a few seconds. As you can see, Git bash has been successfully installed. I'll select this option which says launch Git bash and I'll click on finish button. As you can see, Git bash has been successfully installed. I'll maximize it and I'll zoom in. You can zoom in by pressing Control button and by using mouse wheel to zoom in. Now let's write pwd command, which is present working directory command, also used in Linux. So you can see that it has by default opened Git bash at C drive users a security guru. So that's how you can install Git bash. See you in the next lecture. Thanks for watching. Hello security gurus, welcome to the next lecture. In this lecture, we are going to learn how to create a new code commit repository and connect Git bash with code commit repository. After this tutorial, you will be able to clone any code commit repositories on your local system. Also, you will be able to push any file from your local system to code commit repository and pull any file from code commit repository to your local system. So let's jump into the action. First, we are on this AWS dashboard. We are going to click on get started and we will see this page where we will be able to create a new repository. So let's create a new repository. I will give the name of the new repository as a security guru new repo. I will just click on create. So as you will be able to see, they have given us few steps to install Git and then follow few steps. I'll tell you straightforward few steps using which you will be able to connect Git with code commit. So first let's install Git as well. So this is the URL to install Git. I will put this URL in the resources. You can download the Git for your respective operating system. I am downloading it for Windows. As you can see, we are getting two options, either 32-bit or 64-bit. You can check in your system properties if your window is the 64-bit or 32-bit. If you do not know how to check this setting, let me know. I will be able to help you out. Since I am using 64-bit Windows, I will click on 64-bit Windows setup. So as you can see, it has started downloading. It has downloaded the installer. I will double click on it. This is the installer page. I will click next, then I'll click next, then I'll click next as well. Then it says use bundled OpenSSH, yes. And it says enable experimental support for pseudo consoles. I would not select any option and I will click next. And then it is asking me to install. I will not click on install button since I have already installed Git on my local system. But if you have not installed Git on your local system, click on install and it will install Git on your local system and you will be ready to go. Once you install Git on your local system, you will be able to find Git bash in your Windows search. So open Windows search and type git space bash. And you will be able to see this icon in your Windows operating system. So let's now jump into the action where we will connect our Git with code commit. For that, the next step is to create an IAM user with code commit IAM policy permissions so that we can connect our Git with code commit. So let's open IAM. I'll click on IAM service. It will open the IAM console for us. I will click on users. Now, as you can see, we do not have any users. I'll click on add users. Once I click on add users, I will put a username. So in my case, it's a security guru. I will click on programmatic access since we're using Git CLI. I will click on attach existing policies. I will search for code commit. I will click on full access. I'll click on next and I will click on review and create user. Now since user has been created, I'll go back to IAM. I'll click on users. Now we can see our user. So let's click on this user. This is the user details. Now click on security credentials. Scroll down and you will be able to see this option HTTPS Git credentials for AWS code commit. So click on generate credentials. Now you will be able to see a username and a password. Let's copy it. I'll put this in Notepad. Okay, now we are good with the credentials. Let's close this. Now let's open D drive where I'm going to clone this repo. So I've created a folder AWS Security. I'll open this folder. I'll click on Shift and then right click. I will be able to see this option Git bash here. If you are not able to see this option, then go to Windows search, type Git bash and then open it. Go to the path where you want to clone the repo and you are good to go. Now let's zoom in. In order to zoom in, press Control button and then scroll. Using Control button and mouse scroller, you can zoom in. Let's clone this repo. I'm going back to AWS. I will search for code commit. I'll open it. So this is our repo. I'll click on it. Now I'll click on this clone URL. I'll click on clone HTTPS. Now I'll open our git bash. I'll type, I'll insert the URL, and then I'll type git clone and then our URL to copy, then hit enter. Okay, so we are getting this error. You can also get this error in case you have entered invalid credentials for Git. So in order to delete the existing credentials, you can type credential manager in your Windows search, then go to Windows credentials, click on code commit credentials, remove the existing credentials, then switch back to git bash, type git clone and then URL to clone, then hit enter. Now git bash will ask you to enter your username and password. Now let's enter the username and password that we have received from AWS and password. And hit OK. As you can see, you have been able to clone the repository. Let's go to the location where you have cloned the repository. I have cloned this repository here. If I open it, I will be able to see the .git file here. So in this tutorial, we learned how we can connect our git bash with AWS code commit. In the next tutorial, we will try to push some files in AWS code commit from our git bash. Thanks for watching. See you in the next chapter. Hello security gurus, welcome to this new chapter. In this chapter we are going to download a vulnerable application which is present on my GitHub repo. So I have this Java Reachability Playground which is a vulnerable application. We are going to download this application and we are going to push it to our code commit repository in AWS. So let's start. First we will open this page. Then we will download this code. I will just download this zip, and as you can see, the download has completed. I will show in the folder. This is the Java Reachability Playground master zip. I'll copy it. I'll paste it in the AWS code commit repo that we cloned in our previous lecture. So I'm going to paste it here. Now I'm going to extract this code. Okay, we have now extracted the code. So I'm going to Control A and Control X. And I'm going to paste all the files at the root level, and I'm going to then delete these to the folder and the zip file. So this is now our vulnerable application. I have now switched to git bash. Let's first go into the repo. So I'll type ls. So this is our repo. I'll go into the repo. I'll type cd, first letter of the repo, and then hit tab and then press enter. So as you can see, now we are on the master branch. So let's type git status. We should be able to see the new files. As you can see, we are able to see the new files that we have just added. So let's type git add space star. So if you don't know what is the use of star, so star adds all the files which have been changed. Then we will type git commit -m added vulnerable application and hit enter. Then we will do git push. If you don't know to use git, I've created a separate course on git basics for security engineers. Please go check out my other course. So now as you can see, we have pushed our vulnerable application to the code commit repo in AWS. Now let's switch to code commit repo on AWS. This is our AWS code commit repo, which is a security guru new repo. Let's click on this repo. We need to make sure that we have selected the branch on which we have pushed our code. Since we pushed our code on master branch, we need to select the master branch, and then you should be able to see all the files which we just pushed to our code commit repo. That's great. In the next lecture, we are going to learn how to add a buildspec.yaml file in our code repo so that we can build our project using code build. And then we will try to integrate Sonar Cloud within our project. So see you in the next chapter. Thanks for watching. Hello security gurus, welcome to this new lecture. In this lecture, we are going to understand what is Sonar Cloud and what are its benefits. So Sonar Cloud is a software as a service platform that helps us to keep our source code free from any kind of code quality issues, any kind of code security issues. It also helps us to define quality gates within the Sonar Cloud so that we can set our standards as per the project or organization quality standards. For an example, Sonar Cloud provides a default quality gate where code coverage is defined as 80%. But suppose in our organization or in our project, we maintain 90% code coverage or unit test coverage for any code that we write, then we can define our custom quality gates within Sonar Cloud. So Sonar Cloud has very similar functionality with SonarQube. The only difference is that SonarQube generally we install it on our local system or we install it as a software on our on-premises server or on cloud, but Sonar Cloud has already been installed on our cloud and has been provided as a service so that you can directly integrate your build system with the Sonar Cloud using its APIs, and you are good to go and you can start running quality checks on the source code that your developers are writing. So this is what Sonar Cloud is by a security guru. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to integrate Sonar Cloud within our AWS code commit project. For that, we would need to create a buildspec.yaml file. Now, buildspec.yaml file is a standard format given by AWS using which we can build our project, we can integrate security tools within our project, and also we can run various analysis on our project. Since we have pushed a vulnerable application to our AWS code commit, now we need to create this buildspec.yaml file. So let's jump into the action. So first I will explain the various parts of this buildspec.yaml file, and then we will create this buildspec.yaml file in our AWS code commit repository that we created in the previous lectures. So here are the various parts of this buildspec.yaml. First part is version, where we define the current version of this buildspec.yaml file. So since we are starting, we will keep it as 0.1. Next, we have various phases of the build. So it can be a build phase, it can be a pre-build phase as well, and then it can be a post-build phase. Currently, we have only added a build phase, and within that build phase, we have added few commands. Since our goal is to integrate Sonar Cloud within our AWS code commit repo, so we are running mvn command, which is used to run Maven. Verify is a goal provided by Maven. This is used to run the test of our project. Then we are running Sonar goal, which is used to run Sonar analysis on our project. Then we need to pass some of the information to our Sonar goal. So first information is sonar.project key. We will create this in the next lecture. Then we will need sonar.organization. We will also create this in the next lecture. And then we need to provide the Sonar host URL. Since we are using Sonar Cloud, it is sonarcloud.io. Otherwise, if we had installed SonarQube on EC2 instance, then we would have provided EC2 public IP address and then port to access SonarQube. Since now we are using Sonar Cloud, we have the Sonar Cloud URL, and then we need a token to authenticate to Sonar Cloud and access this project. So let's copy this entire code. I will copy this entire code. Now I'm switching to our AWS code commit repo. This is our AWS code commit repo. Now one thing to notice here is I am on the master branch, and master branch is my default branch. It might be in your case that main is the default branch. So in order to make master branch as your default branch, you can go to settings, then scroll down, then go to default branch, and then you can select the branch which you want as a default branch, and then you click on save. I have selected master branch as my default branch, so that's why it shows master branch as default. Now I'm going back to our repo. I'm clicking on our repo name and I'm going to add a new file. I'll create a new file. I'm going to paste our code. So as you can see, this is our code. Then I am going to give a file name. AWS has provided a standard build spec file name. So the name is buildspec.yml. If you want to keep some other file name, you can give that file name. But we will have to define that file name later at a point as well. In this case, we do not need to make any other change. So that's why I'm giving the default file name, which is buildspec.yml. Then author is a security guru. You can put your name. Then I'm putting the security email. You can put any email that you want. And I'm going to commit our changes. So now, as you can see, our file has been added to the repo. If I go back to the repo, and I can see that my file is present. Yeah. So now in the next chapter, we will first create the Sonar Cloud account. We are going to get project key, project organization and token values. Then we are going to replace those values in this file, and then we will move on to our next steps. So see you in the next lecture. Thanks for watching. Hello security gurus, welcome to this new lecture. In this lecture, we are going to create an account on Sonar Cloud. Then we are going to create a new organization within Sonar Cloud. We are also going to create a new project within Sonar Cloud. Once done, we will create a new security token within Sonar Cloud. These three values we will then enter into the buildspec.yml file that we created in the previous lecture so that we can build our project. So let's jump into the action. In order to create an account on Sonar Cloud, there are four options. We can either use our GitHub account to create an account on Sonar Cloud, or we can use Bitbucket, Azure DevOps, and GitLab. Since I'm already logged into GitHub, I'll click on this and you will see that it will automatically create an account for me, since I've also previously connected my GitHub with Sonar Cloud. For you, it will ask you to log in into the GitHub and then it will create your account. This is our Sonar Cloud dashboard. So in order to create a new organization, we will click on plus and then we will go to create new organization. Now I do not want to import an organization. I will create an organization manually. I'll click on it and I'll give a unique name. So I'll give a name as Java Project AWS. I'll copy this name just for my reference and I'll click on continue. I'm going to use a free plan and I'll click on create organization. Now since our organization is created, let's analyze a new project. I'm going to give a project key. We have given a project key as Java Project AWS. It can be same as organization name as well, and it's going to be public since we are using a free account. I'll set it up. The project key and organization name will be used in our buildspec.yml. Now we are just left with creating a security token. So I'll click on my account and then I'll click on my account. Then I'm going to click on security, and here we need to generate the security token. So I'm going to give a unique name, so AWS token, and I'm going to click on generate. Now as you can see, the security token has been generated. One important thing to note here is you will just see this token only once. If you will move away from this UI or this page to some another page, this token will not be visible. You will have to generate another token. Just for your reference, copy this token and put it in some notepad from where you can refer it later as well. So as of now, I'll just copy it. So now since we have generated a security token, we have also created a project and organization. We will switch back to our code commit repo in AWS. So this is our code commit repo in AWS, and this is the buildspec.yml file that we added to our repo in our last lecture. Let's click on this file. Let's edit this file. So as discussed in the last lecture, we will have to update three values: token, project organization name, and project key value. So let's first replace the token. So I've changed the token. Let's go back to Sonar Cloud and go back to my projects. I'm going to copy my project name. I'm going to switch back to code commit repo in AWS. I'm going to replace organization name and project key. Since I have kept both the project key value and organization name same, hence I have replaced those values. So now the author name is a security guru. You can use any other author name. You can use your email address as well. And then click on commit changes. So now since our changes have been committed, you can see that your token is visible, your organization name has been updated, and your project key is also visible. So now since our buildspec.yaml file is ready, we can now use this to analyze our code commit repo with Sonar Cloud. But before that, we will first have to set up code build to compile our code that is present in code commit. So we will do that in the next lecture. So see you again. Thank you for watching. Hello security gurus, welcome to this new lecture. In this lecture, we are going to create a code build project that will build our code which is present in code commit repo using the buildspec.yaml file. Buildspec.yaml file we created in our previous lectures. If you haven't watched those lectures, please go back to the previous lectures. So once we create a code build project will take the code from code commit and then will build our code using the instructions written in buildspec.yaml file. So let's jump into the action. So this is the landing page of code build. So let's create a new project. So we need to provide a project name. I will give it as AWS project build 1. Then we can add additional tags also. These tags help us to identify whether this project is for production, development or integration environment. We are not going to use it for now. Then it is asking for a source provider where the source code is present. Since our source code is present in AWS code commit, I will leave it like this. Then we need to select a repository. Let's select a repository. Since we have just one repository, which is a security guru new repo, I'll select it. Then it is going to ask for our branch which we want to build. Since our code is present in master branch, I will select the master branch. In case for you it is present in main branch, select that branch. Then it is going to ask an image. So image is basically a machine on which the code will be built. So a managed image are the machines provided by AWS itself. Custom image will be some machine that we will provide to AWS. Since we are going to use a managed image, I will select the operating system. So now AWS is providing these operating systems. I am going to select Ubuntu. Then it is going to ask us a runtime. So I'm going to select a standard runtime. And I'm going to select the latest image available from AWS. Once we have done all the selection, so now AWS is going to create a role. This role will provide authorization to code build to access the code from code commit. So basically this role is having the authorization to read the source code from code commit. So this will be created by AWS itself. We can also give any existing service role or any custom role that we might have created. But since we have not created any role, we will let AWS create this role. Then also we can set up few instructions, like if we are using a VPC, we are using some environment variables, we can provide that information, but we are not using it now. Very important step, we are going to provide the buildspec.yaml file name. Since we are using a standard buildspec.yaml file name, we do not need to provide any name here. In case you have modified your file name, please provide your file name here, and then we are going to create our project. So now as you can see, AWS has created our build project. The code build project name is AWS project build 1. So let's start the build. So what will happen is AWS code build project will pull the code from code commit and will start building it as per the instructions provided in buildspec.yaml file. In buildspec.yaml file, we have given the instruction that we need to run a Maven verify command. Once verify command is done, we need to run the Sonar cloud analysis on our vulnerable code and then identify the issues and submit those issues to Sonar cloud. So let's see what is happening in the logs. So as you can see, the project is being built. The Maven is downloading all the dependencies required in the project. So let's scroll down. As you can see, the project is still being built. The dependencies are being downloaded, and you can also see the SonarQube version 9.0.1 is being used. So let's wait until the SonarQube analysis is complete. As you can see, our project has been successfully built and Sonar cloud analysis has been successfully run, and it is available at this URL. So let's switch to our Sonar Cloud dashboard. Let's go to My Projects. So now, as you can see, the analysis has been run on our project and it says that there are 8 code smells, there are 49 lines of code, but there is 0% coverage. It means that the unit test cases have run, but the test coverage has not been uploaded to Sonar Cloud. So in the next lecture, we will see how to fix this issue. This is a very common issue in real life scenario you will face. I will now explain in the next lecture how we can populate this test coverage in the Sonar Cloud, what plugins we need to add to our project in order to populate this test code coverage. So I will explain about it. So see you in the next lecture. Thanks for watching. Hello security gurus, welcome to this new lecture. In this lecture, we are going to populate code coverage on Sonar Cloud. In the previous chapter, as you have seen, that our code coverage percentage was 0 on Sonar Cloud, but there are few changes that we need to make to our project in order to populate that code coverage. It is a very important lecture as in real time you will face this issue and it takes a lot of research to identify the root cause of it. So in this lecture we will try to understand what can be the possible reasons of having 0% as code coverage in our Sonar Cloud project. So let's jump into the action. First, we will see what we need in order to populate the code coverage on Sonar Cloud. So the first requirement is that we have unit test cases written within our project. So I am going to show you where we have written the unit test cases. I am going into source, then test, then we have Java, and then we have a test class called calculatorTest.java. Now I have added this test class for the demonstration purposes. I have written 2 test cases for it. So let's see the next requirement for populating the code coverage on Sonar Cloud. So the next requirement is in the pom.xml. We need to add a new plugin called Jacoco Maven plugin, and also there should be JUnit test plugin within our pom.xml. And for Jacoco Maven plugin, we need to execute the prepare agent goal, and also we need to prepare a report in the XML format. So how it works is JUnit test will create an XML report of the test execution and it will place at a defined location within the server on which we are running our project. After that, Sonar Cloud will read that location and then will pick up that XML file and then load the code coverage from that particular file. So that's how the Sonar Cloud gets to know about the code coverage percentage. So this plugin you need to add to your pom.xml, and JUnit should be present in your pom.xml as well. I have pushed this entire file and entire repository in GitHub as well, and you can find my GitHub repo in the resources section for implementation. So let's now build this project. So I'm going to go to build and I'm going to go to build projects, where in the previous lecture we created a build project. So I'm going to click on this project and I'm going to start a build. So as soon as the build starts, you will see that the test execution will be run by the Maven verify goal, which we added to the buildspec.yaml file in the previous lectures. Once the Maven verify goal is run, the JUnit tests are run and then it creates an XML file which then gets uploaded to Sonar Cloud. So let's see if our execution has been completed. So as you can see, our build is successful and also the Sonar analysis has been published on Sonar Cloud dashboard under Java project AWS. So let's switch to Sonar Cloud. So this is our Sonar Cloud dashboard. I'll click on my projects and let's see the code coverage. So as you can see, for our project Java project AWS, the code coverage has been populated now. It's 29.2%. Previously it was 0.0%. So as you have seen, we need to make few changes to our pom.xml file in order to populate code coverage on the Sonar Cloud dashboard, or if you are using SonarQube, same requirements are applicable to SonarQube dashboard as well. Another important point to keep in mind is that we need to run Maven verify goal in order to populate this code coverage. So I hope this lecture was useful to you. So see you in the next lecture. Thanks for watching. Hello security gurus, welcome to this lecture. In this lecture we are going to learn how in real world secrets are stored in AWS and they are used in the pipelines. So in the previous lectures we had created one Sonar token which we had placed in our buildspec.yaml file in the repo asecurity-guru-new repo. But in real world we do not place tokens directly in the repositories. We placed it in secrets manager service provided by AWS. So let's start. First what we will do is we will copy the token that we have placed in buildspec.yaml file. So I will open buildspec.yaml file. I'll copy this token and now I will search for secrets manager. So this is the secrets manager service provided by AWS. I have opened that already in a new tab, and this is AWS secrets manager provided by AWS. We want to store a new secret. So I'll select this. It is asking for a key value pair. So the secrets are stored in key value pair. We need to provide a key. So I will give it as token for Sonar and I'll give it a value which we have copied. Yeah, and this is the value. Now click on next. So it is asking for now a secret name. I will name it as first secret. I'm using camel casing and I will click on next. We can also enable rotation for the secret, but we do not need it. So I'm clicking on next and I will click on finish. So now the secret has been stored. As you can see, this is our first secret, and if I click on this, you will see that there is a secret value. If I try to click on retrieve secret value, you will be able to see the secret. Now let's make some changes to our buildspec.yaml file. I'm switching back to our repo. So this is our buildspec.yaml file. I'll edit this file. We will now have to write some commands here. So first command is environment. Now press enter and press a tab. Then we will have to declare that we are using secrets manager. So I'll type secrets -manager and colon again. Now I will hit enter and we will have to press 2 spaces again, and now we will have to type a variable name which we want to use within our script. So I will type a variable name as token in caps. Then I will type the secret name. So secret name was first secret, and then the key name was token for Sonar. Let's check if it's valid. So the secret name was first secret and then the key name was token for Sonar. So we have given first secret and token for Sonar. We have entered the required values for secrets manager. Now let's replace this token variable with the actual value, and we need to type dollar and then the variable name. Now we need to save this file. You can also reach out to us at support@asecurityguru.com. I am going to commit our changes. Okay, now let's go to build project and let's try to build our project and see what happens. Let's start the build. So now the build should fail, and we will see the reason why the build has failed. We have not provided any role to our code build project to read the values from secrets manager. So we need to create one role as well. But before that, we will see first what is the error that is given by AWS, and then we will move towards our next step. So as you can see, the build has failed. Let's see what is the error. The error says that access has been denied to user, which is code build project. Code build project is not authorized to perform read action or get secret value from secrets manager. It means code build needs some permission to read values from secrets. So let's go to IAM, Identity and Access Management in AWS. Let's open it in new tab. Let's switch to that tab. Let's click on roles. So the error says that code build AWS project build -1 service role does not have permission. So let's click on this. Let's scroll down. Let's add some permissions. We can attach policies. Let's search for secrets. As you can see, there is a policy named Secrets Manager Read and Write. Let's select this and attach this policy. As you can see, the policy has been attached to role code build AWS project 1. So let's switch back to our code build project. Let's build the project again and let's see if the results have changed or not. The build has started. Let's see what is happening. There is no error in the project now. As you can see, the Sonar analysis has just started. Let's wait for some time. As you can see, Sonar analysis have been completed and the build is successful. And as you can see, it has finished at this time. So let's switch to Sonar Cloud dashboard, and here you can see that the analysis has just been completed on the entire project. So I hope you have enjoyed this lecture. In the next lecture, we are going to create a build pipeline. So see you in the next lecture. Thanks for watching. Hello security gurus, welcome to this new lecture. In this lecture, we are going to implement quality gate within our AWS code build project. In real life, we need to implement a check where we can make sure that if our quality gate has failed, our code build project also fails, so that we can fix the errors and avoid any kind of production issue. So in order to implement quality gate within the code build pipeline, we need to make few changes within our project. So let's see what changes we need to make in order to implement a security gate and fail our build if Sonar Cloud identifies some security or code quality issues within our source code. For the purpose of this demo, I am using Sonar Cloud, but the same things can be implemented for Sonar Cube as well. So let's jump into the action. So for implementing the security gate within our pipeline, I have updated the buildspec.yaml file. The first step to implement security gate is to add few lines of code within our buildspec.yaml file. So what are these lines of code? I'll walk you through it. So what I have done is I have added a sleep for 5 seconds. after we run the Sonar analysis on our source code, so that as soon as the analysis is complete, we give some time to Sonar Cloud so that we get the results from Sonar Cloud accurately. Next, I have added a YAML syntax. Using this YAML syntax, you can write continuous lines of code. Now, the first line within this line of code is quality underscore status, which we have defined as a variable. On the right side, we are making a curl command which is silent, and we are passing the username information to it. We are passing here the token which we have defined in our secrets manager. Since we are passing token, we do not need to supply the password. That's why after colon there is a space. Now next we are passing the Sonar Cloud URL, and within the URL we are calling Sonar Cloud API. In this API we are calling this Quality Gates API, and we are passing the project key which is Java Project AWS. In case you are using Sonar Cube, replace your URL here. After that, this URL is providing us a JSON file which we are parsing using JQ library, and we are fetching the value of this key which is status. That value is being stored in quality underscore status. Now we are just printing that value, and then we are checking if the value of quality status is equal to error which has been returned by Sonar Cloud, then we are failing the build. In case suppose our analysis is pass, then we will not fail our build. So this is the first change that we need to implement in our code build pipeline. Let's switch to Sonar Cloud projects. So this is the Sonar Cloud project that we created in the previous lecture. So let's click on this Sonar Cloud project. You will see that there is a section quality gates. Let's click on it. You will see that there is SonarWay, which is the default quality gate provided by Sonar. Now in this you can see that conditions are only applied on the new code. So basically it means that as soon as there is a new change in the code, all these checks are applied on that code. But for the purpose of this demo, I have created a new quality gate which is a custom quality gate, and I have added the conditions on overall code and not only the new code. It means that I am checking the entire code whenever there is a new change in the source code. And then I'm checking whether the overall code coverage is less than 80% or not. Suppose it is less than 80%, then I will fail the build, otherwise I will pass the build. So that's how you can define your custom conditions as well. In order to create a new quality gate, you can click on create and you can provide a name, like I have given this name. Let's give it to. Then you click on save. Then you can add a new condition here, and it will ask whether we want to check these conditions only on the new code whenever this analysis will run, or on the overall code. I have clicked on overall code, and then select any measure based on your requirement, and then we need to provide a value, like I have provided the value, and then click on condition. Once you create your quality gate, you need to mark it set as default. Only then it will work for your project, otherwise it will not work for your project. As you can see, our custom quality gate has been marked as default. That's why we are checking the coverage is less than 80% here, but here we have the condition coverage. So this is the process in order to define a custom quality gate. Next thing that we need to say is I'll go to my projects, then I'll click on Java reachability, and then you will see that our quality gate failed because of our condition which is 80% required. In case you do not see this, there is an option that you need to select as well. So SonarCube will ask you, when do you want to run this analysis? When there is a new change or when there is a new snapshot change, you need to select one of the option and then save it. Then you will be good to run your analysis on your new project. So let's move to the next step. As you can see, our quality gate has failed, and the reason was that our coverage is less than 80%. Now let's see what is returned in the API. As you can see, this was the API that we have added to our buildspec.yaml file, and this is the JSON that is returned by the Sonar Cloud API. if you see, we are parsing this value, which is project status dot status and value of the status, which is error in this case. So let's first select the default quality gate that has been provided by Sonar. I will select the SonarWay default quality gate and I will mark it as set as default. And then let's run our analysis. In order to run our build, I'll go to build projects, and then I'll click on AWS project -1. Then I will click on start build. This will start our build. Let's see the results in few minutes once the analysis is complete. Welcome back. As you can see, our analysis have been completed and the build is successful. And also you can see the command that we have given for sleep that has run. And then the analysis has also been printed. Sonar Cloud analysis status is OK. So it means the analysis has passed, and that's why our build has not failed. So let's see the result of the build. As you can see, the build is succeeded, and let's see the result of our project as well. I'll go to my projects, and as you can see, the project has just run and it has been passed. Previously it was failed. So now let's do one thing. Let's click on our project and then go to the quality gates and then select the custom quality gate which we had created. So I will add a condition here on overall code. I will mark the coverage. Coverage means unit test coverage is less than 80%. Then it will fail our build, and I will set this as default, and you should see that it has been set as default for our project. So let's run our build again and see what happens. Welcome back. As you can see, our build has failed now, and if I scroll to the end of the build, you will see that Sonar Cloud analysis status is error. So it means that now it has returned an error. Let's switch to the API just to see what is the status. And as you can see, the status is error here. And the reason is because of the coverage, and the error threshold is 80, but the actual value is 29.2. Let's switch to Sonar Cloud dashboard. And if I go to my projects, and if you see, the quality gate has failed now. And if I click on the exact reason, it will tell us that the first reason is coverage is less, and that the condition coverage is only 50%. So this is related to the test coverage, this is related to the condition coverage. So that's how you implement quality gates within your code build pipeline using Sonar. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we're going to create an AWS code pipeline. AWS code pipeline is a service provided by AWS, which is a continuous integration and deployment service. It means that as soon as there is a change in the code, our pipeline will be triggered and our code will be compiled, and we would not have to build our code manually. This is very important from a real-time perspective because developers will keep on making changes to the code, and we do not want to build our code manually each time there is a new change. Hence, we will create this pipeline that can handle build for us. So let's start. Let's click on create pipeline. We are on pipeline settings. We need to provide a pipeline name. I'll give it as first code pipeline. AWS will create a service role for us, so we do not need to create any service role. Only one thing we need to make sure is there is no space in the pipeline name. Let's go to advanced settings. So in the advanced settings, it is asking us whether we want to store our artifact within a default location or we have a custom location for our artifacts. So we are using default location. Similarly, we are using the default AWS managed encryption key. If you have a different key which you have created, you can use customer managed key. So let's click on next. Now it is asking what is the source provider from where the code will be fetched. We are using AWS code commit. Now what is the repository name? Since we just have one repo, we will select it. Now our branch name is master. We will select our master branch. Then AWS CloudWatch events would trigger our pipeline automatically whenever there is a change. And output artifact format, we will use the default code pipeline format. So let's click on next. Now it is asking for a build provider. Since we are using AWS code build, we will select it. We can also use AWS Jenkins. Now it is asking for a project name that you have already created in AWS code build. We created one code build project, so we will select it. We will click on next. Since we do not want to deploy anywhere, we will skip this stage. We will skip it. And this is our final build pipeline information. We will click on create pipeline. As soon as we create a pipeline, it will start building our code from our code commit repository. So as you can see, the pipeline has been created. Our pipeline name is first code pipeline. Our source is AWS code commit. It already started reading the code from code commit and it has succeeded. Now the build is in progress. So let's see if the build has already started. We will click on build projects and you will see that when we click on our build project, the build will be in progress. So in this way, you can create a code pipeline. Using this code pipeline, whenever you will make a change to your code in code commit, SonarQube analysis will be run on your code each time there is a new change in your code. In the next lecture, we are going to integrate Snyk within our AWS code pipeline. It's going to be an interesting lecture. So I hope I see you in the next lecture. Thanks for watching. Hello security gurus, welcome to this new lecture. In this lecture, we are going to learn about Snyk and its benefits. So let's see what is Snyk. Snyk is an organization that develops security tools which are software as a service. It means that those are available on the cloud and those security tools help us to secure source code which is written by the developers within the organization. These security tools help us to identify security issues within this source code. It is also called as SAST or static application security testing. Next is open source or third-party libraries. So Snyk security tools help us to identify security issues within open source or third-party libraries. Very common example is Log4j. A very high severity issue was recently identified. So now Snyk has released a patch for that security issue within Log4j, and now it identifies all those security issues within Log4j as well. So that is one example. This kind of scan is also called as software composition analysis scan. Third is containers. Snyk security tools help us to secure containers. Containers can be Docker containers or it can be Kubernetes pods as well. Then next and last one is infrastructure as code. So nowadays most of the applications are moving to cloud, and in order to build cloud infrastructure we are writing code. For example, for AWS, we are writing CloudFormation templates, and also we are using Terraform scripts to create infrastructure within AWS Azure and other cloud platforms. So Snyk helps us to identify configuration issues within the code written in Terraform and other cloud platform templates. So this was the definition of Snyk and its benefits by a security guru. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new chapter. In this chapter, we are going to learn how to add a new stage to our code pipeline, and also we will try to integrate Snyk in that stage. So let's jump into the action. We will open our pipeline which we created in the previous lecture. This is our first code pipeline. Let's add a new stage in this pipeline. I'll click on edit. I'll click on add stage. I'll give it a stage name. Since we're currently running Snyk for SCA, I'll type Snyk SCA and click on add stage. Now I'll add an action group, and I will have to give an action name. So it's SCA analysis from Snyk. I'll select an action provider, which is Snyk in this case. I'll choose the input artifacts, which is our source. Then I'll connect to Snyk with our GitHub account. So I'll click on GitHub. I've authorized Snyk to use my GitHub account, and it is asking to create an organization on my behalf. So I've selected as a security guru as an organization. It is asking that whether we want to stop our deployments whenever Snyk finds an error. So I would uncheck it because we are not going to do our deployment. It is also asking that whether we want to block deployments for vulnerabilities with a specific severity. So this is selected in case we want to stop our build if there are low severity issues, high severity issues, or medium or critical severity issues. I'll select it as low. It is asking me to select monitoring behavior on build. I'll select as never monitor and I'll click on continue. Now it is asking to process OAuth request. I'll click on confirm. So it has confirmed that we have successfully configured the action with this provider. We also need to provide an output artifact name. So I will give it as Snyk SCA analysis output and I will click on done. As you can see, we have added Snyk SCA action to our build pipeline. Let's save this pipeline. I'll click on save. As you can see, the pipeline was saved successfully. I'll click on release change and I'll click on release. As you can see, the pipeline build has started. It is fetching the latest changes from source code and then it is going to run the Snyk SCA. As you can see, the source code has been fetched. Now it is trying to run the Snyk SCA. Snyk will run source code analysis on our code present in code commit. We will see the output from Snyk within our pipeline. As you can see, the Snyk SCA analysis has been completed. Let's see the details. As you can see, the Snyk test report has been generated and it has identified these vulnerabilities within our source code which is present in AWS code commit. So that's how you can run Snyk SCA analysis along with Sonar Cloud analysis on the source code and create a powerful CI/CD build pipeline which is secure. I hope you have enjoyed this lecture. Thanks for watching. Please leave your comments in case you have any questions. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we are going to learn about OWASP ZAP and its benefits. So OWASP stands for Open Web Application Security Project, which is a non-profit organization that works towards increasing the security of our software. They have released the ZAP product, which is Z Attack Proxy, and is a very popular product. So let's see what Wikipedia has to say about OWASP ZAP. So as per Wiki, ZAP is an open source web application security scanner. It can be used both by the new penetration testers or by the professional penetration testers. It is one of the most actively maintained and very well renowned open source web application project and has got the flagship status as well. Now, what are its benefits or differentiators? It can be used to scan both web applications as well as API specifications. So that's why it's very much popular. It's used in enterprise organizations as well for scanning web applications and API specifications. It helps us to identify security issues in both of web applications and API specifications, and it's widely used. In the next lectures, we are going to implement ZAP with GitHub Actions. We will take a vulnerable web application and then we will run ZAP on that vulnerable application and we'll see how many security issues ZAP is able to identify in that, and we will see the effectiveness of ZAP. I hope you have enjoyed this lecture and you learned something new. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we are going to see how to store code build artifacts in S3 bucket. So let's jump into the action. I am on AWS code build getting started page. Let's click on build projects page. As you can see, this is our build project, AWS project build -1. Let's click on it. Once you click on it, you will be on the build history page of AWS project build -1. You will be able to see the edit option. Let's click on it. Then you will be able to see the artifacts option. Let's click on it. Then you will be routed to edit artifacts page. Here you need to select the type where you want to store your artifacts. So I have already selected Amazon S3. So you can select this option. Once you select this option, you will have to select an Amazon S3 bucket name. Let's click on it and you will be able to see the available S3 buckets to you. Since I'm using the code pipeline US East 1 bucket, I'll select it. And that's it. You just need to scroll down and select on update artifacts option. Once it's done, the artifacts for build project has been successfully updated message will appear, and that's how all your artifacts that will be generated from this build project will be stored in the S3 bucket. And you can see the location of S3 bucket. It says that artifacts upload location is this S3 bucket that we just selected, and now for all future builds the artifacts will be uploaded to this S3 bucket. In the next lecture we are going to integrate OWASP ZAP and we are going to store our DAST scan reports in this S3 bucket. So stay tuned. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to integrate DAST scan using OWASP ZAP within our AWS DevSecOps pipeline. So let's jump into the action. In order to integrate ZAP within our AWS DevSecOps pipeline, we need to write some code within buildspec.yml file. So I've opened buildspec.yml file already within our AWS code commit repo, which is a security guru new repo. So let's see the code that we have written for integrating ZAP. So in fifth line, we have used the YAML syntax pipe symbol. So this is the pipe symbol that we have used. Using this, we can write multiple commands with a line break. So the first command that we have written is apt-get update. This is used to update the Ubuntu machine that we are using to run our code in AWS. Then we are installing wget utility on this Ubuntu machine. After that, I am installing default JDK or the latest JDK available to install on Ubuntu machine. After that, I am downloading ZAP using wget that we installed, and then I'm creating a directory ZAP using mkdir command. Then I am unzipping the ZAP file that we just downloaded using wget command. The command to unzip a file is tar command -xvf. When we will unzip this file, it will create a directory zap underscore 2.11.1. So I'm moving into that directory using cd command or change directory command. Then within this directory, there will be a file named zap.sh. I'm passing a parameter to zap.sh. The parameter name is cmd. Cmd stands for command line. Then using quick URL parameter, we are passing a URL on which we want to run the DAST scan. The URL name is https www.example.com. So this is a test web application on which we are going to run the DAST scan. Quick progress parameter is used to print progress within the logs. So we will be getting the percentage completion of DAST scan in the logs. Then quick out parameter is used to generate a DAST report. I'm providing the DAST report name and I'm saving it at the root directory. Then we have written code to store the zap underscore report.html file in the artifact. So the artifacts will be stored in an S3 bucket and the file name that will be stored will be zap underscore report.html. So this is the entire code that we need in order to integrate ZAP within AWS DevSecOps pipeline. So let's commit these changes. In order to commit, I'll give the author name, which is A Security Guru. I'll provide the email address, so which is support@asecurityguru.in, and then I will commit our changes by clicking on commit changes. As you can see, buildspec.yml has been committed to master. Now AWS will automatically start running the code as we have created a AWS build pipeline. So let's go to code build. I'll click on code build and I'll click on build projects. Now we are on build projects, and as we had created a build project in the previous lectures, this is our build project, AWS project build -1. Let's click on it. As you can see, we are on the build history page of our AWS project build -1, and you can see that our project has already started building, and the reason was that the build was triggered by our code pipeline that we created. As you can see, the build has already started and currently it's in progress. Let's click on build run to see the logs of the build. As you can see, the build is currently running. I'll scroll down, and as you can see that the zap was downloaded and unzipped. Then the current Java version is 11. Then it started accessing the URL. It started using traditional spider. The active scanning was on, and then progress you can see in the logs. As you can see here, it was 79%. If I scroll down, we should be able to see the 100% progress. So here, as you can see, the scan is completed and 100% progress is visible. It has also written that attack is complete and the results were written to zap_report.html. The output file was found and the upload artifacts action has also succeeded. So let's see the file that has been uploaded. In order to see the results, we will have to go to build details. So I'll scroll up. I'll click on build details. I'll scroll down and you will see a section named artifacts, and you will see that the artifacts are being uploaded to this location. Let's click on it. As you can see that the artifact was just created now. Let's click on it. Once we click on it, we will be able to see the object details here and the S3 URI of the artifact as well. Let's click on download button to see the report. As you can see, the zip file has been downloaded. Let's open this zip file. So this is the zip file that has been downloaded. You can see the name and you can verify that we have downloaded this zip file YQ1 as PUL, and this is the zip file that is currently downloaded. Let's click on zap_report.html present in this zip file. As you can see, the zap report has been opened successfully and it provides the entire details. So this was the website on which the DAST scan was performed. This is the timestamp. You can see that there is one medium severity issue identified and two low severity issues identified. And these are the details of the issue. If we scroll down, we will also see the mitigation provided by OWASP ZAP for each security issue identified. So you will be able to see all the three issues that have been identified. So being a security engineer or DevSecOps engineer, your responsibility will be to go through each security issue one by one, identify whether it's a true positive or false positive, and then work with dev team to resolve those issues. You will have to report all the true positives in Jira or ServiceNow and assign it to dev team. Once dev team fix those issues, you will have to rerun the scan, and then that will be your day-to-day responsibility. I hope you have understood how to integrate ZAP within AWS DevSecOps pipeline and enjoyed this session. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we will learn how we can work with a VPC while we have our code in AWS code commit and code build. So let's jump into the action. In order to access some resource within a VPC from your code build, what you need to do is you need to open your build project. So this is our build project. Let's click on this. Then we need to click on edit and we need to go to environment. Once we go to environment, we need to click on additional configuration and we need to go to VPC. So basically here we need to select a VPC that your AWS code build project will access. So what will happen is once you select a particular VPC, this code build project will be able to access any resource that is present within this VPC. You will have to select the appropriate subnet and also you will have to select the security group of that VPC. Once you update the VPC values, you need to click on update environment. So now the changes have been made in the AWS code build project. Let's go to the VPC. I'll search for VPC. I'll click on this. I'll click on our VPCs. So this is our VPC that we have selected in our code build project. Let's create a VPC endpoint. As you can see, there is no VPC endpoint. I will click on create endpoint. I'll give it a name as VPC code build endpoint. Then it is asking for the service category. Since we are using AWS services, I'll keep this selection. Then I will search for code build. As you can see, there is a code build service. I'll select this. I will select the VPC. I'll select the subnet. I'll select the subnet ID. And I will select this security group and I will click on create endpoint. So now all the settings have been done. Your code build project will be able to access any resource that is present within this VPC. So that's how you work with the VPC. Whenever you have some resources in the VPC, you need to create the VPC endpoint and you need to update those specific values of VPC within that AWS service so that you could access VPC resources from the other AWS service. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we are going to understand a case study where we are going to implement an end-to-end DevSecOps pipeline in AWS for a Java project. This case study is similar to a real-life enterprise environment where you will have to implement DevSecOps pipeline that should contain static application security testing, dynamic application security testing, and software composition analysis scan in the pipeline. So it's going to be really interesting. It's going to be really hands-on and similar to a live environment. So let's jump into the action and understand this case study. The case study is that a developer will commit its code to a Java repo. Once the code is committed to the Java source code repo, we need to build that code using the Maven build tool. Maven build tool is very popular and used across many organizations. So we will use Maven to build that Java project. Once we build that Java project and run the unit test, we will run the Sonar Cloud analysis to run static application security test on the source code. The Sonar Cloud will help us to identify the code quality and security issues within the source code. Once we perform Sonar Cloud analysis, we will run software composition analysis scan using Snyk on our source code. Snyk will identify any security issue within the third-party libraries that are being used within our source code. Once we run the software composition analysis scan on our source code, we will run dynamic application security testing scan using OWASP ZAP on our web application after deployment. That will cover SAST, SCA, and DAST within our DevSecOps pipeline. Once all these security security scans are completed, we will have to perform false positive analysis on the reports generated by Sonar Cloud, Snyk, and OWASP Zap. So we will perform false positive analysis on each security issue identified by these security tools. We will determine whether those security issues are true positive or false positive, and then we will report those issues in the ticketing tool like Jira and ServiceNow, and we will assign those tickets to developers to fix these security issues, and that will complete our end-to-end DevSecOps cycle within a real-life environment. So it's going to be really interesting. It's going to be really insightful that will help you to be prepared for an enterprise environment and implement DevSecOps pipeline in real projects. So stay tuned and thanks for watching. Hello security gurus, welcome to this new lecture. In this lecture, we are going to implement an end-to-end AWS DevSecOps pipeline for a Java project. This pipeline will have static application security testing, software composition analysis, and dynamic application security scans within it. So in order to implement this end-to-end DevSecOps pipeline, we will need to update two files. The first file will be buildspec.yml, which will contain the entire code that we need in order to implement this pipeline. The second file will be pom.xml, which we will need to update in order to add all the dependencies required for this end-to-end DevSecOps pipeline. So let's see the changes in both these files. I am on AWS Code Commit repo, and we have this repo within AWS Code Commit. The name of the repo is A Security Guru new repo. I have opened the file buildspec.yml within this repo. Now let's see the code that we have written for implementing end-to-end AWS DevSecOps pipeline. The first line is version 0.1 that we are using for buildspec.yml. After that, we have declared an environment variable. We are using secrets manager. We have created a secret, first secret, and we are using the key token for Sonar, and we are storing the value within token variable. After that, we have defined few phases for our DevSecOps pipeline. The first phase is build phase. Within build phase, we have written some commands. The first command is for implementing static application security scan using Sonar Cloud. We are running a Maven goal, which is verify goal. This is used to run unit test within our project. After that, we are running Sonar analysis on our source code using sonar:sonar. Sonar analysis will require few parameters. The first parameter will be sonar.project key. We are passing the project key that we have created within Sonar dashboard. After that, we are passing the Sonar organization that we have defined within Sonar Cloud, and then we are passing the Sonar host URL, which is sonarcloud.io. After that, we are passing the sonar.login token, which we are fetching from secrets manager. This will implement our static application security scan within AWS DevSecOps pipeline. After that, we have defined few quality gates on SAST scan using Sonar Cloud. Once the Sonar analysis run, we are waiting for 5 seconds so that Sonar analysis is complete. After that, we are using YAML syntax, which is pipe symbol that is used to write multiple commands with a line break. After that, we are using a curl command to make a Sonar Cloud API call. We are passing the project key to that API, which is Java project AWS. This API will return us a JSON response. We are parsing it using JQ library, and we are parsing the value of project status, which is present in status variable, and we are storing it in quality underscore status variable that we have declared. In the next line, we are just printing the value of quality underscore status. After that, we are checking if the quality status value is equal to error, then we are failing our build. It means that our quality gate has failed. If it is different than error, then we are not failing our build. But just for the demonstration purpose, I've commented this line so that our build does not fail and we can see all the scans. I'll scroll down. After that, we have implemented software composition analysis scan using Snyk. We have again used the YAML syntax, which is pipe symbol. We have written few commands. The first command is to update all the packages on the Ubuntu machine. apt-get is the package manager on Ubuntu. After that, we are installing Maven command using apt-get. In the next line, we have defined a Snyk token. So this is the Snyk token that we generated from Snyk dashboard. We are creating an environment variable using export command of Linux, and the environment variable will be Snyk underscore token. This is required for running our sneak analysis. After that, we are running again Maven goal, which is sneak test, and we are passing -fn flag to make sure that our build does not fail even if the sneak identifies some security issue. So -fn flag is used to avoid any kind of build failures, but this is just for demonstration purpose. In real life scenario, we want to fail our build in case there are any security issues identified by the security tools. So this is the entire step for implementing software composition analysis scan within our pipeline. The last part is related to dynamic application security scan using OWASP ZAP. We are again using the pipe symbol here. After that, we are updating the packages on Ubuntu. After that, we are installing wget utility on Ubuntu. This is the wget utility. After that, we are installing default JDK on Ubuntu. After that, we are using wget to download Zap proxy for Linux. After downloading Zap proxy, we are making a Zap directory. Then we are using tar utility to unzip the Zap file that we have just downloaded. Then we are changing our directory to Zap directory that will be created after unzipping our Zap package that we downloaded. We are changing our directory to zap_2.11.1. Then within that directory, we are running zap.sh file, which is a shell script file. We are running it in command line. We are then passing a URL. The URL will be www.example.com. This is a test website that we are going to use for running a DAST scan. This is just for demonstration purpose. After that, we are going to print the progress of DAST scan in the logs using quick progress parameter. We are going to store our DAST report using quick out parameter. The report name will be zap_report.html and this will be stored on the root location. The last line of code is related to storing DAST reports in S3 bucket. We are using artifacts keyword to store our DAST reports in S3 bucket. Then we are giving the file name using files keyword. The file name will be zap_report.html. So this is the entire code that we have written for implementing end-to-end AWS DevSecOps pipeline for a Java project. Let's see the changes that we have made within pom.xml. I'll switch to the other tab where I have already opened pom.xml. Here we have added some dependency changes that we need in order to implement this end-to-end AWS DevSecOps pipeline. The first change is for unit test coverage to be populated on Sonar Cloud dashboard. We have added JUnit plugin within our pom.xml. The second change is related to again populating code coverage on Sonar Cloud dashboard. We have added a Jakuko plugin as well with the goal to generate the report in the XML format. So this plugin is also required for populating code coverage on Sonar Cloud. The third change is related to software composition analysis scan using Sneak. We have added a Sneak plugin within our pom.xml to run the software composition analysis scan. Within this plugin, we have given the organization name created within Sneak account. So these are all the changes that we have made within pom.xml. In the next lecture, we are going to run these changes in order to view the results of SAST, SCA and DAST scans within our end-to-end AWS DevSecOps pipeline. So stay tuned. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to view the results of our end-to-end AWS DevSecOps pipeline for the Java project. So let's jump into the action. This is the buildspec.yml that we have written for implementing this end-to-end pipeline. I'll just make a small change within this pipeline so that it gets automatically triggered. I'll just remove some text from this pipeline and then I'll commit this change so that it is automatically triggered by the AWS code pipeline. I'll give the author name as A Security Guru. I'll provide the email address as support@asecurityguru.in and then I'll commit my changes. As we have committed our changes, you can see that changes have been committed to the master branch of this repo and this is the commit ID. Let's move to AWS code build. I'll click on it. Let's click on build projects. Now this is our build project, which is AWS project build -1. Let's click on it. Now we are on AWS project build-1 landing page, and you can see that our build has already started running and it's currently in progress. You can see that it has just started and it's been just 1 second since it was started. Let's wait for some time to view the results. Hello friends, welcome back. As you can see, our build has succeeded and you can see the submitter of this build. It was submitted by code pipeline automatically by detecting the changes in our buildspec.yml and pom.xml files. The duration of the build was around 3 minutes 34 seconds. It took around this much time to complete all the three phases of the build, which were SAST, SCA and DAST scan, and also uploading the results to S3 bucket. As you can see, the build was completed just now. Now, in order to see the logs of this build, we will have to click on build run. So let's click on it. Now we are on build status page and you can see the status of the build is succeeded. And in order to view the entire log of this build, we will have to click on this link. So let's click on it. It will open a new tab and within that tab we will be able to see the logs. You can see that the CloudWatch logs are loading and now the log events are being populated. Let me scroll up. You can see that CloudWatch logs have been populated and there are a number of log events. Let me search for our first scan, which was static application security scan using Sonar Cloud. I'll type Sonar Cloud and hit enter. It will now just load the events related to Sonar Cloud. You can see that Sonar analysis was successful and you can find the results on Sonar Cloud dashboard. If I click on it, we will be able to see the same detail. So it means that our Sonar analysis has been successful. Let's check for sneak analysis, which is software composition analysis scan that we ran. I have typed sneak here and I'll hit enter. You can see that Sneak has ran an analysis on our project. The project name was Java Reachable Goof and Sneak executable path was this, and it has identified many security issues within our third-party libraries. You can see that these are the security issues that have been identified. There are deserialization of untrusted data security issue, which is medium severity, and you can see that it has identified many security issues, and at the end it says that failed to execute goal because Sneak was able to identify many security issues within our source code and hence it has failed the build. But since we used -FN flag, our build was not failed. So that's why this flag is used to avoid any build failures. But this is just for demonstration purpose. In real life environment, we do not use this flag as we want to fail our build in case there are critical severity within our source code. Let's see the final phase of the build, which was OS Zap. I'll type Zap here and hit enter. As you can see, the Zap was downloaded and unzipped on our Ubuntu machine. Let's scroll down and you can see that the Zap analysis was complete and the result was written to zap_report.html. So that's how you implement an end-to-end DevSecOps pipeline within AWS for a Java project. I hope you liked the implementation. Thanks for watching. See you in the next lecture. Hello security gurus. Welcome to this new lecture. In this lecture, we are going to create a Jira account in order to report security issues to the development team. So let's jump into the action and how to create a free Jira account. I am on google.com and I will type create Jira account and I will hit enter. After we type create Jira account and hit enter, we will be able to find this URL on Google, which is atlassian.com, and the title of the web page is free Jira software from Atlassian. Since Jira is from Atlassian, we will open this URL. Let's click on it. As you can see, we are now on atlassian.com. And within that, we have selected the Jira software. Let's click on next button. Now Atlassian is asking us to log in either using Google or with any other email ID to create an account with Jira software. I'll choose Google account. Let's click on it. Now we need to sign in with our Gmail ID. I will type my email, which is gurusecurity@gmail.com, and I'll click on next button. After that, I'll type my password. As you can see, our login is successful, and now we are being routed to atlassian.com with our Google account. As you can see, our Google account is now visible. This is my Gmail ID. Now let's provide a unique name for our Atlassian site. I will provide the name as a security guru test. As you can see, the name is available, and our site will be created as a security guru test.atlassian.net. Let's click on agree button. As you can see, Atlassian is setting up our site, so it might take few seconds for our site to be live. Let's wait for few seconds while Atlassian is creating our Jira site. As you can see, our site has been successfully created. You can verify the domain. It is asecurity.gurutest.atlassian.net. Within that, it is asking us to provide some information to set up Jira. So let's provide some information. I'll say that I'm experienced with Jira. I'm experienced with agile methodologies, and we are going to spend our time working on fixing bugs, which is security bugs, and we have a tight schedule to finish our work. I'll click on next button. It is asking us to provide a project name. I will provide it as Fix Security Issues for DevSecOps Project. Key is auto-populated, that's fine. Let's click on Create Project. It is asking us to select some tools if we want to connect those tools with our Jira project, but I will skip this step for now. Now it is giving us option to invite our teammate. If we have multiple team members working on our project, we can add them with their email address. But right now, since we do not have any other team member, I'll click on continue button. As you can see, our Jira project has been successfully created. The Jira project name is Fix Security Issues for DevSecOps Project. In the next lecture, we will start reporting some security issues within Jira that will help developers to fix those issues. Stay tuned. Thanks for watching. Hello security gurus, welcome to this new lecture. In this lecture, we are going to report a security issue found during static application security testing that we ran using Sonar Cloud. We are going to report the bugs in Jira software. We created the Jira account in previous lecture. For this demonstration purpose, I am using Vulnado application. This Vulnado application has been scanned by Sonar Cloud already, and it has identified a very high severity security issue within the source code. So we are going to report this issue, which is a command injection issue. So let's see how to report this issue in Jira. I'll switch back to Jira dashboard. Now, for the purpose of this demo, I've already created a bug that I reported for this issue. But let's first see how to create this bug within Jira. In order to create a bug, you need to go to backlog. Now within backlog, you will see create issue option. Let's click on it. On the right side, you will see these three dots, which will help you to open create dialog. Let's click on it. Once we click on it, create issue dialog box will open, and you will have to enter all the details here in order to create an issue. And once done, you will click on create issue button. That's how you create an issue within Jira. One thing to notice here is that while reporting security issue, we need to select issue type as bug, since these are bugs identified within source code. So let's go back to the active sprint. Click on cancel button for now. I'll go to active sprint, and I will open the security issue which I have reported already. Now let's see the details that we should fill in order to help developers to fix this issue. The title of the issue says that this is a DevSecOps scan, which is a SAST scan, and we have found a high severity issue for Vulnado application. Type of the issue is command injection. Now let's see the description. I'll zoom in. So within description, you will be able to see the scan details mentioning that this is a vulnerable scan, the SAST scan, and we ran this SAST scan in CI/CD mode, and I have added the commit ID because of which this CI/CD scan was run. We can see this commit ID on Sonar Cloud. I'll switch to Sonar Cloud. If I go to summary of this scan, we should be able to see this commit ID. Let's go back to Jira. After that, I have added the source file path in which this issue has been identified. You can see the file path here. This file path is also visible on Sonar Cloud. I'll switch back to Sonar Cloud. I'll go to security hotspots and you can see the file path here. I'll go back to Jira. After that, we have added the file name which is visible in this file path. Then we have added the vulnerable code function. Vulnerable code function says that this function is vulnerable. This function is mentioned in Sonar Cloud. As you can see, this function was highlighted by Sonar Cloud. So I've added that code within Jira issue. Now after this, we have added that line number 11 in Cause Java file has the security issue. After that, we have added the issue description, which we have copied again from Sonar Cloud. As you can see, if I go back to Sonar Cloud and I'll scroll down, you will see that we have added this detail as the issue description within Jira. If I scroll further, you will see that we have added references. These references will help developer to see what can be the possible mitigation for these issues. These references you can also find within Sonar Cloud. I'll go back to Sonar Cloud. I go to how can you fix it tab. I scroll down. You will see the references as well. I'll go back to Jira again. Now scrolling further down, we have added vulnerable category, which in this case is injection, the vulnerability severity, which is high in this case, and the security analyst who worked on it, which in this case is a security guru. The environment on which this security issue was identified, which is dev environment, and we need to assign it to the correct developer who will be working on this. We have also added this bug to sprint 1. It means that this bug should be fixed in sprint 1. I have assigned the priority high because this is a high severity issue. So priority I have kept as high as well. So that's how you report a security issue found in SAST scan in Jira. Let me close this issue. So once you report this issue and this issue is assigned to developers, developer will move this issue to in progress once they start fixing this issue, and once they fix this issue, they will change the assignee of this issue to your name, and then you can retest this issue. Once you feel that this issue has been fixed, you can move it to done stage, which is the final stage. This is a typical example of Kanban board that we have used within Jira. I hope you understood what information you need to provide to developer in order to fix a security issue. I hope you learned something new. It was helpful to you. Thanks for watching. See you in the next lecture. Hello security gurus. Welcome to this new lecture. In this lecture, we are going to understand how to report security issues found during software composition analysis scan. As you know, SCA scans are used to identify security issues within third-party libraries. We have used Snyk to identify SCA security issues. So we are going to use one sample of security issue identified by Snyk for this demonstration purpose. So let's jump into the action. I am on Jira dashboard and I have created this security issue which I reported for SCA scan. I have used Snyk security issue that was identified in SCA scan. This is the security issue that was identified. It was related to arbitrary code injection that was found in Morgan library, which is a middleware library used for Node.js. The issue was identified in 1.9.0 Morgan library and can be fixed by upgrading that library to 1.9.1. Now we are going to understand how to report this issue. I'll switch back to Jira dashboard. Let's open this issue and understand what details we need to provide while reporting a security issue found during SCA scan. I'll open this issue. Now In the title, as you can see that we have given the DevSecOps as this issue was identified while running the DevSecOps pipeline. The scan type is SCA scan. The severity type is medium. Node SDK is the project name. Morgan is the library. And 1.9.0 is the library version in which the issue was identified. Now let's see what description we have given. We have given the scan details. We have given a unique scan detail as application name, which is Node SDK. SCA scan is the scan type and CI/CD scan is the type of scan that we ran. If you have a scan number, you can assign that as well at the end of this name. Now let's move to issue description. We have provided an issue description here, and this issue description we have received from Snyk. I'll switch to Snyk. And if we go to overview, this is the issue description that has been provided by Snyk. We have added that to the issue. After that, if we go further down, we will see that we have given the standard IDs to this issue, which are CWE94, CVID and CVSS score that has been assigned to this issue. We've also received this information from Snyk. Let's see that in Snyk. As you can see on the top, we can see this information that has been provided by Snyk. Let's switch back to Jira. If I scroll further, you will see that we have provided vulnerable path as well, as this issue was introduced by the parent library, which is Node Test 2, and it is calling the child library, which is Morgan 1.9.0. This vulnerable path was also provided by Snyk. As you can see, the vulnerable path is present here, where it says that Node Test 2 is the parent library and Morgan is the child library. Let's switch back to Jira. Then we have given the safe version of the library. It means that if we upgrade Morgan library from 1.9.0 to 1.9.1, this issue will be fixed. This is also provided by Snyk. As you can see that upgrade to Morgan 1.9.1 is the fix of this security issue. And finally, we have provided the references, which is also present in Snyk. If we go back to Snyk, you can see that this is the reference provided by Snyk. Let's go back to Jira. Finally, we have given the vulnerability category, which is injection in this case, the severity, which is medium, and the security analyst who is working on it, which is a security guru. We need to assign it to the developer who will be working on it, and also we need to assign it to the sprint in which this should be fixed. Let's change the priority to medium, as this is a medium severity issue, and let's close the issue. So that's how you report a security issue found in SCA scans. Once a developer will start working on it, developer will move this issue to in progress, and once developer fix this issue, it will reassign this issue to you as a security engineer. You need to retest this issue and move it to done stage here, and that will close this issue. So that's how you report a security issue found during SCA scans, assign it to developers, retest it, and then close these issues. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to understand how to report a security issue found during DAST scan that we ran on our web application using OWASP Zap. So let's jump into the action and see the details. I am on Jira dashboard and I have created a security issue for DAST scan. For this demonstration purpose, I am going to open a Zap report that we created using OWASP Zap. We ran this DAST scan on https://example.com. The dynamic analysis produced one medium severity issue and two low severity issues. So we are going to report the medium severity issue in Jira. So let's see the details. I'll open this issue that we created for DAST scan. Let's now understand the title of the issue that we reported for DAST scan. DevSecOps is the pipeline in which this issue was found. The type of the scan is DAST, which stands for Dynamic Application Security Testing. Severity of the issue is medium. The domain or web application on which the scan was run is http://example.com. The issue is Xframe options header is not set. Now let's see the description that we have added. We have added scan details where we have added the application name as the prefix. Then we have given the type of scan, which is DAST scan. The nature of the scan is CI/CD scan, and we have appended timestamp to the scan. The URL scanned was example domain. So all the URLs related to example domain were scanned. Then we have added the issue description. The issue description we have received from OWASP ZAP report that we generated. I'll switch to ZAP report. I'll scroll down. We can see the detail of this issue. As you can see, the description of the issue can be found here, and we have entered this description in our Jira ticket that we are creating. The description has been entered from the ZAP report. We have also provided a possible mitigation, and this possible mitigation has also been extracted from the ZAP report. As you can see, ZAP has provided a possible solution of this issue. After that, ZAP has provided the reference details, the CWE ID, and we have entered these details as well. The standard ID we have provided as well, which is CWE ID 1021. We have also received it from ZAP. As you can see, CWID 1021. Then we have also added the reference details from this ZAP report into our Jira issue type, which is reference, and the reference URL. Also, the vulnerability severity is medium in this case, and the security analyst who was working on it is a security guru. On the right side, you will see that we have given the label as example.com. So this is the domain on which the DAST scan was run, and the sprint in which the issue will be fixed is sprint 1. We have assigned medium priority to this issue. I'll close it. So once this issue is assigned to developer will move this issue to in progress. Developer will implement the fix, and then it will be reassigned to you to retest it. We as a security engineer will have to retest it and then move it to done stage, which is the final stage in this case, and then issue can be closed. So that's how you report a security issue as a security engineer or DevSecOps engineer. Related to DAST scan in Jira, you assign it to developer fixes it, you retest it, and then you close that security issue. I hope you enjoyed this entire workflow. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this next chapter. In this chapter, we are going to learn about the AWS Security Hub. AWS Security Hub is a very special service from AWS which provides a consolidated view of your security status in AWS. AWS Security Hub integrates with AWS Macie, AWS Config, AWS Inspector, and then retrieves the security findings from the various other security services within AWS, and then presents a central dashboard where you can view all those issues that have been identified by the various other security services, and then you can set up some security actions based on the kind of issues identified. It can be based on severity of the issues as well. So let's see what is Security Hub in a diagrammatic representation. As mentioned by AWS, AWS Security Hub helps us to automate our security checks. We can run automated security checks as well. We can set up some AWS security best standards across our AWS environment, and if those standards are not being followed, AWS Security Hub will raise it as a concern as well. It also helps us to have a consolidated view of the security findings being identified by Amazon GuardDuty, Inspector, Macie, and AWS Config and similar other security services. Once those findings are fed into the AWS Security Hub and are visible to us in a dashboard, we can then take appropriate action. It can be an automated action, or it can be just an email being sent to a senior security engineer or the DevOps engineer who is managing the environment. Since now we have understood about AWS Security Hub, in the next lecture we are going to implement AWS Security Hub within our environment, and we will see a live demo of it. So see you in the next chapter. Thanks for watching. Hello Security Gurus, welcome to this new lecture. In this lecture, we are going to implement AWS Security Hub within our infrastructure. In the previous lecture, we learned about the basics of Security Hub. Now we are going to implement those basics. So let's jump into the action. We are getting a 30-day free trial. So let's click on Go to Security Hub. Once we click on Go to Security Hub, we arrive at the landing page. As a prerequisite, we need to enable AWS config in order to enable AWS Security Hub. The reason is that the resource recording will happen in AWS config, and AWS config will start recording the configuration for each and every service within AWS. Once a standard has been set, then if there is any deviation in that standard, those findings are fed into the Security Hub. That's why it has been mentioned as a prerequisite. So let's go to AWS config console first and enable it. I've clicked on AWS config console and I will switch to that window. So this is AWS config landing page. AWS config records and evaluates configurations of your AWS resources. It means that as soon as a new resource is created within AWS, AWS config will create a record of that service with that particular configuration when it was created. Now suppose after a few days, if there is any change in that AWS resource, AWS config will make a deviation from the standard, and if there is any issue in the new configuration, it will raise it as a finding and it will be fed into the Security Hub. That's why it has been mentioned as a prerequisite. So let's click on Get Started. Here they are asking us to enable the resource type for which we want to do the recording. We want to record for all resources supported in the region, and also AWS will create a service link role that is required, and it will also create an S3 bucket in which these changes will be stored. So let's click on Next. Now there are few rules which AWS config will implement. These rules will be used to identify any issue in the configuration. If a new resource is not configured as per these rules, it will be marked as an issue and it will be fed into the Security Hub. So let's select all rules and we will click on Next and we will click on Confirm. So the signing up with AWS config has started, and AWS has started enabling the AWS config within our infrastructure. It has successfully created the rules. So let's view the dashboard for AWS config. As you can see, it has started identifying the resources that are non-compliant as per the rules that we have just enabled. It takes some time to populate these values. So let's switch back to Security Hub now. So now we are on Security Hub landing page. Let's see what are security standards. So as I mentioned, AWS provides us few standards or best practices that should be followed across the entire AWS infrastructure that you have created. It has given CIS AWS Foundation Benchmark and also Foundation Security Best Practices published by AWS. If we are working on a particular banking application or credit card application which needs to be followed as per PCI DSS compliance, we can also enable it, and all the rules defined in these three standards will be implemented across the infrastructure. So in case there is any change or any deviation from these standards, it will be raised as an issue within Security Hub. Right now we will enable for all three, and then let's click on Enable Security Hub. As you can see, all these standards have been enabled and these have been successfully enabled across the infrastructure. The values will be populated but in few hours. AWS as mentions it can take up to 2 hours. So in real life scenario as well, based on the number of services that you have in your infrastructure, time can increase for your infrastructure to populate these values, because more the number of services, more time it will take to evaluate those services against these standards. So that's why it can take some time in real life as well, but generally in 2 to 3 hours I have seen these values populated. You can see these are findings by region. Since we have enabled Security Hub just for this region, that's why the findings only from this region will be populated. So in my real life project where I was working on Security Hub, we had enabled Security Hub for multiple reasons, and findings from all those regions used to be visible here. So you can do that as well. Then once the data is populated, it will also show the findings by provider and severity, and these are the various graphs that have been provided by AWS. If there are some findings in S3 bucket, it will be populate here. If there are some findings in EC2 instance, it will be populate here. So for an example, in my previous project where I was working and implementing Security Hub in AWS, there was one finding where the S3 bucket was publicly exposed, and we could see that issue here in the Security Hub dashboard once we enable it. So then we quickly fixed it and we saved a lot of confidential data. So Security Hub helps you to implement security standards and best practices across your infrastructure, and also it helps to identify any issue in all the services across your infrastructure. Very common example is S3 bucket exposed to internet. I have seen more serious issues where network security group was exposed to the internet with all the ports open. We had to fix that issue at the earliest, and it saved us from greater risks. I hope you have enjoyed this lecture. See you in the next lecture. Thanks for watching. Hello security gurus, welcome to this lecture. In this lecture we are going to learn about Amazon Inspector. Amazon Inspector is also another security service which can be integrated with Security Hub. You might be confused. We have learned about Guard Duty, how it's different from Amazon Inspector. So I'll tell you the difference. Guard Duty scans all the logs within the various services and then identifies some meaningful security finding out of it. But in case of Inspector, Inspector checks about software security issues and also checks about the configuration related to network security groups, where it will try to find the security issues. So basically Inspector focuses more on the software aspect and the configuration aspect of the services, where Guard Duty analyzes the logs within S3, within CloudWatch events and similar services. I hope you now understood the difference between Inspector and Guard Duty. So let's see what else we have in AWS Inspector. I have switched to the AWS Inspector diagrammatical representation so that we can understand it better. As AWS mentions, Amazon Inspector is an automated security vulnerability management service that checks software vulnerabilities for your resources and also about the network exposure. Network exposure means that whether you have configured your security groups correctly or not. If there is some security group exposed to the internet, it will highlight it as a security finding. So that's how Amazon Inspector helps. Once you enable the Amazon Inspector with a few clicks, you will be able to generate all the findings from various AWS accounts as well. You can connect this Amazon Inspector to multiple AWS accounts. Then there are some features listed of Amazon Inspector which are automatic and continual scanning. Also, it maintains some database where all the vulnerabilities are stored and everything happens in real time. Then once meaningful findings are identified by Inspector, you can take the appropriate decision based on the finding identified. You can create a ticket in Jira, or you can ask the infrastructure team to look into the configuration of that resource. That's how you can take action on these findings. So I will share my experience where I used Amazon Inspector in my previous project. We had one security group which was exposed to the internet and Amazon Inspector highlighted it. So we were able to fix that issue quickly. So let's see how we can enable Amazon Inspector. I will switch to Amazon Inspector homepage, and as you can see, we get a 15-day trial for the accounts which are new to Inspector. So let's click on Get Started. Once we click on Get Started, it will ask us to provide IAM service permissions to enable Inspector. So let's enable Inspector and provide the required permissions to generate the findings for us. Now, as you can see, we have enabled the Amazon Inspector for us, and you can see that first scan is underway. It means that it will start analyzing all the resources for us. It will try to identify the software security issues. It will try to identify the configuration issues, and then it will generate these findings. You will be able to see these findings here on the Amazon Inspector dashboard, and also you will be able to see this information on Security Hub dashboard as well. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we are going to review the findings identified by AWS Amazon Inspector. So let's jump into the action and see how we can identify security issues within EC2 instances using AWS Amazon Inspector. Let's jump into the action. There are few steps in order to integrate AWS Inspector with our EC2 instances. So I have highlighted the steps in this page. So the steps are that we need to create an EC2 instance with port 80 enabled in the security group. That is required for the agent to communicate with the inspector. Now, second is we need to install SSM agent on the EC2 instance. SSM is AWS Systems Manager agent. So this agent is required to be installed on EC2 instance, and this is required for any kind of communication between EC2 instance and AWS Inspector. So we need to install this agent as well. So there are few Amazon machine images which already have SSM installed on it. In case you want to install it manually, I have provided the link as well. So this is the web page from which you can install it. Let's see this web page. Now this is the web page provided by Amazon. In this, as you can see that in order to install the agent on a Linux based EC2 instance, we need to download the agent installation using the wget or curl command. Once we download it, we need to install it, and then agent will start communicating from the EC2 instance. So basically the agent will start sending the health information from the EC2 instance. There is also information in case we are using an window based EC2 instance. I have already done this installation. I'll bring up the EC2 instance on which I have installed this agent. Now, as you can see, the agent that I installed on this EC2 instance is communicating successfully and is sending messages. So these are the logs of this agent. I am using the Amazon Linux release 2 as an image of this EC2 instance. I'll come out of the logs. We will see the commands that we have used to install it. I'll scroll up. As you can see, I use the wget command to download it. Once downloaded, I use the install command to install it. So after that, you can see that installation went successfully and agent was successfully installed on this machine. Now let's switch back to our Amazon Inspector. Let's see the findings that have been reported by Amazon Inspector. As you can see, it says that port 22 is reachable from the internet. If I click on it, we will be able to see the details that port 22 is reachable from the internet from our EC2 instance. Let me open our EC2 instance. I'll go back to EC2 instance console. Now this is the security group attached to the EC2 instance. As you can see, within this security group, port 22 is open to the internet. As you can see, SSH port is open to the internet. The port is 22 and the source is any IP address from the internet. If I go back to our EC2 instance, let's click on the instances that are running. As you can see, this is the instance name, ASG Inspector, the instance ID. Let's match it with the finding that has been identified by Inspector. As you can see, the source ID is I095T, and if we see the instance ID, it is also the same I095T. So hence you can verify that this finding has been identified for the AWS EC2 instance, as we just have one EC2 instance running within our AWS account. You can validate the VPC ID, the subnet ID, and the AMI that we are using. If we scroll down, you will see that this is the open network path attached to our instance. Let's also see how to create an assessment within AWS Inspector using the Inspector Classic console. I'll click on Inspector Classic console. As you can see, I just ran one assessment and there have been 5 recent findings. I'll click on it to see the findings. As you can see, there are 2 medium findings and 3 informational findings. Let's see the medium findings. As you can see, the assessment is also saying that the instance, which is our EC2 instance, is configured to allow users to log in with root credentials over SSH without having to use a command authenticated by a public key. This increases the likelihood of a successful brute force attack. And this rule is defined within Security Best Practice rule package. Similarly, we have another finding from Network Reachability rule package. So these were the findings that were identified by the Amazon Inspector with the assessment that we run against the EC2 instance. Now let's see how to create an assessment. I'll click on the dashboard option. As you can see, there is a link, help me create an assessment. I'll click on it. As you can see, there are 2 options to create an assessment within Amazon Inspector Classic module. One is network assessment and one is host assessment. Network assessment does not require Inspector agent to install, but host assessment requires Inspector agent to be installed. Let's click on advanced setup to see how to set up the assessment. As you can see, it is asking us to provide a name to this assessment. I'll provide it as -01 just for this demonstration. It is asking us to include all the EC2 instances available within the account region with the AWS account and region. I have selected yes. Similarly, it is asking us to install the Amazon Inspector agent on EC2 instances. We have selected yes as well. To install Amazon Inspector agent, EC2 instance should have SSM agent installed already. We have already installed SSM agent. Let's click on next button. Now it is asking us to define an assessment template. I'll provide it as 01 and it is asking us to select the rules package. These are the few options within rules package. We can keep all of these rules selected. The only drawback will be the assessment will take more time to run against our EC2 instance. The duration recommended is 1 hour and we can keep the assessment as a recurring assessment as well. I'll uncheck this for now and I will go to next. Then now this is the summary. I'll scroll down and as you can see, now we will create the assessment. You can see this message, the assessment run has started, run command has been successfully issued. So that's how you create an assessment and run it. I had already created an assessment few minutes back and as you can see, I ran it just around 30 minutes back and the analysis was complete and 5 findings were identified. When we clicked on the findings, we were able to see that there were 2 medium findings and 3 informational findings, and these findings were mapped against the rules. So the one medium finding was mapped against the security best practice rule. So this rule failed, that's why this finding was created. Similarly, network reachability rule failed, that's why medium finding was created. So that's how you run the assessment using the Amazon Inspector Classic dashboard. And also the Amazon Inspector V2 findings can be seen by going to all findings and you should be able to see the findings here. So we learned in this lecture how to use Amazon Inspector V2 and Amazon Inspector Classic dashboard and how to enable Amazon Inspector for an EC2 instance, connect EC2 instance and Amazon Inspector and identify the findings. or security issues within our EC2 instance configuration. I hope you enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this lecture. In this lecture, we are going to learn about Amazon Detective. Amazon Detective helps to analyze and investigate about the root cause of the security findings or about the suspicious activities. It keeps on analyzing the logs within the AWS services, and it helps us to visualize and identify the root cause in an efficient manner. It's very easy to enable Amazon Detective in our AWS infrastructure. As you can see, the category it falls in is in around forensics. For an example, if we are analyzing the PCAP file for a Wireshark, we might be analyzing some kind of network data that might be flowing from source to destination. Similarly, here we will be analyzing the logs that have been printed, and we will try to identify the root cause of a security incident. For an example, in case of denial of service attack, in that case we will have to identify from which IP address this attack is coming so that we can block that IP address. For such cases, Amazon Detective is very helpful as it provides visual functionality. So let's see how the service page of Amazon Detective looks like. So I'm already on the Amazon Detective's homepage, and this is how it looks like, and this is the cost related to it. It's very easy to enable it, and we get a 30-day free trial as well. So let's click on Get Started. As you can see, this is the landing page of Amazon Detective, and there is a new functionality available. Now it supports AWS organizations as well. I'll explain what is AWS organization in a separate chapter. Let's enable Amazon Detective. As you can see, we have enabled Amazon Detective on our AWS infrastructure, and it has identified our AWS account, which is this account ID. Now the Amazon Detective has been enabled. Now it will start going through all the logs present, and then it will try to keep those logs and provide us the visual functionalities to help us identify the root cause of some security finding. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to learn about Guard Duty, since Guard Duty is also available as an integration with Security Hub. As you can see, the type of integration available is where Guard Duty is sending findings to Security Hub. So we need to understand what is Guard Duty. Guard Duty is a threat detection service. It keeps on reading the VPC flow logs, CloudTrail management flow logs, and other logs, and tries to identify the malicious behavior so that it can protect our AWS services. I'll give you a very common example where Guard Duty would have helped. In my previous project, there was one EC2 instance which got hacked, and there was hackers who were running the mining jobs on that EC2 instance. In that case, Guard Duty would have identified that there is unusual processing being used on that EC2 instance, and we would have stopped that from happening. That's how Guard Duty helps us to save our AWS services. We will enable the Guard Duty within our infrastructure. Hello security gurus, we are going to implement Guard Duty for our AWS infrastructure. So this is the AWS Guard Duty landing page. As you can see, AWS provides us 30-day free trial for Guard Duty. So let's click on Get Started. Once we click on Get Started, it will ask you to provide Guard Duty permissions to analyze all logs within CloudTrail, VPC, DNS query logs, so that it can analyze what kind of payloads or what kind of malicious data is being sent into that log so that it can generate some security findings. So let's enable Guard Duty. Once we enable the Guard Duty, it will start scanning our entire logs, and then it will start generating the findings for our action. In my previous project, I had implemented Guard Duty where we had huge data within the logs, and Guard Duty was able to identify some confidential data being written to the log, and then we had to change our code to mask that data being written to the log. So such kind of findings will be given by Guard Duty. I hope you have enjoyed this lecture and you have understood how to implement Guard Duty for your AWS infrastructure. In the next lecture, we are going to review the findings generated by Guard Duty. Thanks for watching this lecture. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to review the findings generated by Guard Duty. So let's jump into the action and see the results produced by Guard Duty. we are on guard duty dashboard, and you can see that this is the finding generated by guard duty within our AWS account. So let's click on it to see the details of this finding. As you can see, this finding was related to using root credentials from this IP address. The action that was performed for root credentials was API list assessment action was invoked using the root credentials. The severity of the finding was low. The region is mentioned, it was US East 1. The account ID, which is our current account, is mentioned. The time when this finding was raised. The access key was used, that's why the resource affected has been listed as an access key. The user that was impacted was root. Similarly, if we scroll down, we will see the action that was performed. It was AWS API call. The API list assessment was invoked, and the service that invoked it was Audit Manager. And if we scroll down, it will provide us the remote IP address and IP details. Let's close this detail. Now, another very important option within guard duty is to suppress findings. Now, there can be a scenario where some of the findings are internal, like in this case, and we do not want to create any kind of alert based on it. So, what we can do is we can suppress those findings by clicking on suppress finding option and creating a suppression rule. As you can see, once we create the suppression rule, it will automatically send the matched findings to archive, and the auto archived findings are still generated, but they do not generate a CloudWatch event. So that's why we use suppression rules to avoid creating any CloudWatch events in case those findings are known and we do not want to generate any events. In order to create a suppression rule, we need to provide a rule name. I'll provide it as test finding suppression rule. I'll provide a filter that will match the finding with this filter. I'll provide the filter as finding type. I will select this finding. I'll select this finding type value. I'll copy it and paste it here, and I'll click on apply button. And now we can save this rule. As you can see, our suppression rule has been successfully created. So going forward, any kind of finding matching with this filter will be auto archived, and CloudWatch event will not be triggered for that finding. Now let's see the other settings within guard duty which are very important. The first setting is list. This list is related to the trusted IP list. If we know that some of those requests which guard duty is considering as malicious requests are coming from known IP addresses, we can upload a list of trusted IP so that guard duty does not generate findings for these IP addresses. As you can see, trusted IP list consists of the IP addresses that are known, and guard duty does not generate findings for IP addresses. So hence, if we are seeing that we are generating some requests from known IP addresses, but guard duty is considering those requests as malicious, we can upload that list of IP address within guard duty, and guard duty will not generate it as a finding from those IP addresses. How to upload an IP address list? By clicking on add a trusted IP list, then providing a list name. I'll provide it as test list. Then we can upload the file containing the list of IP address in S3 bucket, and then we can select the particular format. It can be a CSV format, it can be a plain text, it can be a structured threat information expression, or it can be a CSV file from these systems. So that's how you upload a trusted list of IP addresses within guard duty. The next important functionality within guard duty is enabling S3 protection. So currently I have enabled the S3 protection for the account. Similarly, we can enable the Kubernetes protection as well. This is a new feature that has been released where guard duty will generate findings from Kubernetes audit logs as well. Another important functionality within guard duty is accounts functionality, which we can use if we are having multiple AWS accounts. We can have a single security account where we can set up a guard duty, and then we can invite child AWS accounts from the security account, and we can add all those accounts for scanning with guard duty from the security account. We can invite other AWS accounts by clicking on add accounts option. We need to provide the account ID and email address, and then we can add those accounts. That way we can control guard duty from a central account by adding all the other accounts to the central security account where we have enabled guard duty. So that is all about guard duty. We learned how guard duty generates finding, how to archive the finding, how to add a trusted list of IP address within guard duty, how to enable S3 protection in Kubernetes, and how to invite other AWS accounts to a central account of guard duty. I hope you enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this lecture. In this lecture we are going to learn about the AWS IAM Access Analyzer. AWS IAM Access Analyzer is a feature that monitors and analyzes the policies that have been applied to our AWS resources from IAM. IAM stands for Identity and Access Management, and this feature helps us to implement policies across our AWS resources, and IAM Access Analyzer analyzes all those policies that have been implemented. When Access Analyzer identifies that an external account has access to our AWS resources, it generates a finding. So let's go to the service homepage. This is the service homepage where it says that you create an analyzer first. You define the scope of the analyzer, like for which account you want to check IAM policies. Then it will analyze all the IAM policies applied to AWS resources. Once analyzed, after that it will give us findings, and findings will be visible in the Security Hub if Access Analyzer is integrated with Security Hub. Then third, we will have to take action based on the type of finding that is visible in Security Hub. So let's create an analyzer. So this is the name by default which is given. I will keep it as is. This is the account for which analyzer will analyze the policies. Then I'll click on create analyzer, and analyzer will be enabled for this account. As you can see, analyzer creation is complete for this account, and it will start analyzing all the IAM policies applied to the resources within this account. We will be able to see the findings within the Access Analyzer dashboard here as well. So I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we are going to learn about Amazon Macie, which is a security service from Amazon which uses machine learning algorithms to automatically identify sensitive information within our AWS S3 buckets. Yes, so this service is specifically for identifying confidential information being stored in S3 buckets. Confidential information can be related to PII data, PHI data, credit card related information, and similar other confidential information. This service falls in the category of data loss protection and data classification. So let's see how the service homepage looks like. I have switched to Amazon Macie homepage, and as you can see, it clearly tells us that it automatically discovers sensitive data across the organization S3 buckets. So let's enable it. I'll click on get started. Here also Amazon Macie needs some IAM role permissions in order to identify confidential information within the Amazon S3 buckets. So I will click on enable Macie. As you can see, Amazon Macie has been enabled and it has started identifying information across the S3 bucket. In my previous project where I was implementing, it identified that there was some confidential information related to the end customer, and we had to mask that data in order to safeguard against any compliance issues. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello Security Gurus, welcome to this new lecture. In this lecture, we are going to see the results produced by Amazon Macie. In the previous lecture, we implemented Amazon Macie in our infrastructure. In this lecture, we are going to see those results. So as you can see, Amazon Macie has identified that there are two S3 buckets and both are not publicly accessible. It means that Amazon Macie checks whether that bucket is publicly accessible or not. It has also checked that whether there is encryption enabled or disabled on those S3 buckets. Then also it checks whether there is sharing enabled on those buckets or not. So let's click on one of these issues and see what information we see. So this is the first S3 bucket, which is for code pipeline, and if you scroll down, we can see the object statistics that are available in that S3 bucket. We can also see that encryption is enabled and we are using SSC KMS managed keys. We will learn about KMS in the next video. Then we are also able to see server-side encryption enabled on the bucket, and also then we can see that bucket is not publicly accessible. Also, it shows us whether there are any block public access policies enabled through access control list on those S3 buckets. So as you can see, Macie helps us to identify all kind of issues with these S3 buckets while identifying confidential data within the S3 buckets. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello Security Gurus, welcome to this new lecture. In this lecture, we are going to learn about the various integrations available in Security Hub. So the first integration that we are going to learn about is AWS Audit Manager. AWS Audit Manager continuously audits our AWS infrastructure and matches all the services against regulations and industry standards. For an example, PCI DSS standard that we enabled within the Security Hub, and then the findings are fed into the Audit Manager. Similarly, there is another standard that we enabled in the previous lecture, that was AWS Best Practice Standard, that has been developed and provided by AWS, which checks all the AWS services against the given best practices, and then it brings up the findings and then fed it to the Audit Manager. So as you can see, the type of integration which is available is receive findings from Security Hub. How to send the findings? This integration is automatically enabled when we enable the service. We are going to learn about the AWS Audit Manager and we are going to implement it in our AWS infrastructure. But before implementing it in our AWS infrastructure, we are going to learn about the architecture provided by AWS. So in this architecture, AWS mentions that first we create a framework for Audit Manager, which we have created and selected in Security Hub. So we selected three standards. One was related to best practices of AWS, second was related to CIS benchmark, and third was related to PCI DSS. Once we select a pre-built framework, we then define the scope of the assessment, like in which region these standards will be evaluated for the services. And then once the standards are selected and the scope of assessment is finalized, then the assessments are activated and it keeps on continuously gathering the evidences for all the services in the AWS. And also it conducts any kind of reviews, control reviews, and we can also delegate it to other resource owners. Once the review is completed, finally the audit ready reports are generated, which we can present to our stakeholders. So let's jump into the demo of Audit Manager. This is the landing page of AWS Audit Manager. You can see the pricing as well for the Audit Manager. So for first month, for 35,000 validations, it is free. After that, per 1,000 validations, we are charged $1.25. So let's click on set up AWS Audit Manager to enable it for our infrastructure. Now, as you can see, in order to get started, they are asking us to select our data encryption preferences, and they are asking us to enable AWS Security Hub and config to assess security checks. Since we have already enabled AWS Security Hub and config in our previous lectures, so we will move to the next steps. AWS will create data encryption keys for us. We would not select any key. It will automatically customize our encryption settings. In case you have specific KMS keys, you can select your KMS keys here and it will be loaded. As of now, since we do not have any KMS key. There are no keys loaded out here. Let's click on complete setup. As you can see, setup has been completed and AWS Audit Manager has been enabled. I hope you have enjoyed this lecture. So see you in the next lecture. Thanks for watching. Hello Security Gurus, welcome to this new lecture. In this lecture, we are going to create an assessment within the AWS Audit Manager. We enabled AWS Audit Manager in the previous lecture. So if you have not watched the previous lecture, I would recommend you to first watch that lecture so that you can enable AWS Audit Manager and then you will be able to create an assessment. Now, first question is why we need to create an assessment. We need to create an assessment because that assessment is a prerequisite in order to collect any data within the AWS Audit Manager dashboard. So AWS Audit Manager dashboard says that you must have at least one active assessment that's collecting automated evidence. So let's jump into the action and create an assessment. I'll click on create assessment. First, we need to provide an assessment name. So I will give the name as first a security guru assessment. Then we need to select an Amazon S3 bucket. So I will select one bucket from the list. We can create a new S3 bucket as well, just specifically to save the audit manager reports. Then we need to select some framework. So I will select the AWS Audit Manager sample framework and then we will click on next. We need to specify for which account we want to run the AWS Audit Manager. Since we have just one account, we will select that account. In my previous project, we were working on multiple accounts. So we enabled AWS Audit Manager only for those accounts where we were the responsible parties. So I have selected this account for now and I'll click on next. It says that since this assessment is created from a standard framework, Audit Manager will automatically map and select the data source and service in scope for you. So it will automatically identify the services that are in scope for us for this particular AWS account and then it will run the standard against those services. So let's click on next. So it is now telling us who are the audit owners here. There can be multiple users and we can select user who is the responsible stakeholder for this audit. But since here it is only one user, which is your A Security Guru. So I will select that user and click on next. And now it is asking us to review and create that assessment. So let's click on create assessment. As you can see, we have created our first assessment and we are able to see some control sets which have been created and some controls which are under review. We can also see the AWS accounts which have been selected, the AWS services which are being reviewed, and currently the status of the assessment is active. As you can see, AWS Audit Manager is actively collecting evidence for these 5 controls and all the 5 controls are under review for these 3 AWS services. So that's how you create an assessment in AWS Audit Manager. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello Security Gurus, welcome to this new lecture. In this lecture, we are going to see the integrations that we enabled for Security Hub and we are going to see what results Security Hub produces and how it helps a security engineer to implement security practices within AWS infrastructure. So let's jump into the action. As you know, in the previous lectures, we enabled 3 benchmarks while we were setting up Security Hub. One was related to CIS AWS Foundation benchmark and you can see the rules within this benchmark. Out of those rules, 11 have passed and 30 have failed. In the next standard PCI DSS, which is mostly applicable to credit card related organizations, and under that there are few rules defined. Out of that, 32 are passed and 13 are failed. And similarly, AWS Foundation Best Practice Framework published by AWS, for that standard 135 rules have passed and 18 have failed. So out of these 3, there is an average which is generated and we have a security score of 72%, which means that higher the security score, better the security implementation within our infrastructure. On the right side, you can also see that most of the resources which have failed the security checks. You can see that there are 43 checks for our AWS account. For our AWS S3 bucket, there are 8 failed checks. Similarly for code pipeline as well. And there is VPC issues highlighted and the security group that we have attached to this VPC that also has failed check. Now let's see the severity of these findings. There are 8 critical findings and 8 high findings. There are 34 medium and 21 low findings. Then we have the insights by provider and severity. You can see that here also it highlights by time when we had less findings and when we have more findings. Next we can see that there is findings related to S3 buckets, and if we scroll further we will see that the integrations that we have enabled with Security Hub for Amazon Guard Duty, we can click on it and it will show us these findings. And similarly there are no findings from others. For Guard Duty, the findings are flowing from Guard Duty to Security Hub, and based on that the insights have been generated where it shows that AWS resources with most findings, we have 14 AWS resources with this result. Similarly, S3 bucket with public read or write permissions, there are 0 S3 buckets related to it. So what happens is Guard Duty has implemented the security checks, analyzed our resources, and then it sent the findings back to Security Hub, and then the Security Hub generated the insights. That's why we have an insights section as well within Security Hub. So that's how the Security Hub presents the data. So let's open some of the findings so that you can understand what kind of issues are generated. So I will click on these 8 critical findings, and you will be able to see that these are the 8 critical findings which have been generated. So the first finding is related to hardware MFA should be enabled for root user. This finding is generally everywhere. I have seen this in my previous project as well, because hardware MFA is related to hardware infrastructure and most of the organization would not implement this feature. So you can click on this and suppress this feature as well. So in order to suppress it, you can click on the workflow status and you can mark it as suppressed. So in real life you will have to go through all the issues. You will have to take appropriate decision. Like in this case, we know that hardware MFA would not be implemented by the client. So I will click on this and mark it as suppressed so that next time it does not get generated within this list. So let's click on this critical finding. As you can see that this is also related to hardware, and we know that hardware MFA would not be implemented. We can suppress this finding. To do that, we will go to workflow status and we will click on suppressed, and you will see that it will be removed from the list. So that's how you can fix the findings based on the appropriate decision. So being a security engineer, you will have to go through all the critical high medium findings. You will have to work with various product teams or different AWS teams to take the appropriate actions and then generate a report and then present to your leadership with what actions you have taken, how many security findings you have fixed, and how many are still open on which you need to work on. That will be your weekly work, and that's how you will work in a real organization. So I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we are going to learn about AWS WAF, which is Web Application Firewall, and also we are going to understand what is AWS Shield. Now first let's understand what is AWS WAF. So AWS WAF is a web application firewall that protects against the malicious attacks. So all the web requests coming from API gateway, Amazon CloudFront distribution, or any application load balancer, all those web requests can be protected using web application firewall. You can define various rules within this firewall, and you can also define regular expressions in the firewall. So let's see how that works. So first we will have to create a web ACL. ACL means access control list. So let's click on create web ACL. Once you click on create web ACL, first we will have to provide a name to the ACL. So we will give it as first WAF ACL. Then it is automatically fetched name that we have given for ACL. So let's keep it as is. Now it is asking where do we want to implement this web ACL. So in my previous project where I was working on AWS, we had deployed many APIs in API gateway and we had attached this firewall to the API gateway itself. Whatever requests that were coming from API gateway, we had implement few regular expression rules in order to identify any kind of cross-site scripting attacks. So that's how you can use web ACL. So let's keep the regional resource selection as is. Now if you can see, this is optional, but you can add AWS resources deployed on Amazon API Gateway, Application Load Balancer, and AWS App Sync. Since we do not have any resource deployed right now, we will leave it as is. Let's click on Next. Now we can add rules to the web ACL. Now either we can create our own rules or we can use AWS created rules. So if we click on Add Managed Rule Groups, we will see that there are many kind of rules available. We can use AWS created rules or we can use rule groups created by third parties as well. So as you can see, these rule sets are available from the marketplace. We will have to subscribe to these rules from AWS marketplace if we want to add these rules to our AWS ACL. So let's use as of now AWS managed rule groups. I will add a bot control rule group. Then we can add admin protection. We have the Amazon IP reputation list. IP reputation list is if there are few IPs which are blocked and from where we are getting the request, the ACL will block all the requests coming from the blocklisted IPs. Anonymous IP list, so if there is a request coming from a system who does not have any IP, this rule will block that request. Suppose in case you have deployed any automation framework on Lambda and it is sending requests to your API gateway, so in that case there won't be any IP address attached and in that case it will get blocked. We had this issue in our previous project and all those requests coming from the automation framework got blocked because of this rule. So we had to disable this rule. So I have enabled some of the rules and I've consumed some of the capacity. So let's click on Add Rules. As you can see, we have used 225 of the capacity out of 1500. As you can see, the total capacity units of the web ACL cannot exceed 1500. So make sure that the rules that you are adding do not exceed 1500. Otherwise, you will have to select only the prioritized or the most important rule sets. So let's see what else is there. Now we have the default web ACL action for requests that don't match any rules. It means that if suppose there is any request which do not match any rule, what do we want to do with that request? Do we want to allow it or block it? So as of now, we will keep it allow. If you have a preference to block it, you can block all other requests. So now you can set the rule priority. Basically, it means that we can arrange our rule sets based on the priority. For an example, we want that nobody shall be able to launch any admin attack. So this is the most important rule for us. We can move it up. Similarly, if suppose the availability of our APIs or application is most important for us, I will move this rule at the top. So that's how we set the rule priority. We'll click on next. Now we can enable some metrics or sampling option. Sampling option means that AWS will keep on monitoring the requests that are coming to this ACL and then it will show us some graphs. In case we disable the sample request, we won't be able to view those graphs, but if we enable it, we will be able to see some of the graphs. So better we keep it enabled and click on next. As you can see, this is the summary. We have given this name and CloudWatch metric name was generated by AWS. Then we have added these rules to our ACL. We have used 225 capacity. And we have allowed all the requests that do not match any of the given rules above, and we have enabled the sampling of the request as well. Let's create our first web ACL. As you can see, the web ACL has been created. Let's click on it. As you can see, now you can see the request per 5-minute period. Basically, it means that after every 5 minutes, the graphs will be refreshed. Also, you can see these graphs based on the time duration for 3 days or 1 day. As of now, the graph has not been populated. Once we will start receiving the request, this graph will be populated. It takes some time to populate this graph. Then we can see the sampled request here. So what will happen is all the requests that are allowed or blocked will be shown here with an action allow or block at the right. In my previous project where we implement this, we could see all the blocked requests that failed the rules. And that's how we got to know someone was attacking with cross-site scripting attacks on our APIs. So this sampling request will help you to identify the reason why the request was blocked or allowed. What are the rules are there? So these were the rules that we had added. We can add more rules from here again. If suppose you want to add more rules, once you have created the ACL, you can use these options to add the rules. Let's see bot control, where AWS will present you any graphs where it identifies that some bots are sending the request. So you will see orange color for the bot request, and for non-bot request you will see the blue color. So the data will be populated once the requests are sent to API gateway, and API gateway is connected to AWS WAF. Let's see the associated AWS resources. Now, in case in future we have more APIs created and deployed to AWS API Gateway, we can click on Add AWS Resources and we can select all the new APIs that have been created and click on Add. Now we can have a custom response body. Now suppose we want to send a custom response to specific request, we can do it from here. On the logging and metrics, we can see that the logging is disabled, but we can enable it from here. So let's click on enable. You can see that it asks where do we want to send our logs. We can send our logs to CloudWatch logs group, or we can send to Kinesis for the analytics, or we can store our logs to S3 bucket. If we select Amazon CloudWatch log, we will have to create a CloudWatch logs log group here. So we will have to create new, and then we need to select that log group here itself. If we want to omit any data being stored within our logs, we can select these fields based on the information being sent. Suppose if there is any confidential information in any of these fields, you can redact those fields from the logs. So as of now, I'll click on cancel as I do not want to enable logging. Let's see what is CloudWatch log insights. So basically, once we will enable our logging and metrics, CloudWatch will generate some insights based on the information being stored in the logs, and it will be able to present the insights here itself once we have some data in the logs. So that's how you create a web ACL using WAF provided by AWS. In the next video, we will see how we can create regex patterns, what are the use of regex patterns, and how we can attach those regular expression patterns to our web ACLs. So I hope you have enjoyed this lecture. Thanks for watching. See you in the next chapter. Hello security gurus, welcome to this new lecture. In this lecture, we are going to create a regular expression pattern set for AWS Web Application Firewall, and then we are going to use that regular expression pattern within our Web Application Firewall access control list. So let's jump into the action. In order to create a regular expression pattern set, we need to click on regular expression pattern set link on the left side under AWS WAF. Then let's click on create regular expression pattern set button. I'll click on it. Once we click on it, we will land to the create pattern set page. Now we need to provide a regular expression pattern set name. Let's give a meaningful name. I will give it as stop cross-site and HTML attacks. So we are going to create a regular expression to stop cross-site scripting and HTML attacks on our web application. Now let's scroll down. The region in which I'm going to create this regular expression pattern is US East. Now we need to write a regular expression. If you are not aware about the regular expression syntax, then let's use a website which is very helpful. I'll switch to that website. So this is the website name regex101.com. In that I have created a simple regular expression using which we can stop some HTML and cross-site scripting attacks. As you can see, this regular expression will identify any request that might contain an HTML keyword, div keyword, script tag, script with small letters, or alert tag in the request. We can also test this regular expression. Here you can see a test string that I have written. If I just remove this string and I write a new string like script with capital S, you will see that it will again say that it matches this regular expression. So that's how you can create a regular expression. These special characters, you can see that this website also explains what is the use of this character. So this is the meta escape character which asserts position at start of a line. Then we are matching any character and then followed by that we are matching with the previous token. At the end we are ending this regular expression. So you can use this website. On the right side as well you will see the explanation related to the regular expression that we have created. Let's copy this regular expression and switch back to AWS WAF. Let's paste this regular expression and click on create regular expression pattern set. As you can see, our regular expression pattern set has been created. Let's use this regular expression pattern set within our web access control list. Let's click on it. This is our web ACL. Let's click on it. Let's click on rules tab. Let's click on add rules. Let's click on add my own rules and rule groups. Now you will see that we can create our rule type. I will select the rule builder and I will provide a rule name. So this rule will be used to block HTML or XSS attacks. We are using this rule as a regular rule, but we can also use it as a rate-based rule. Rate-based rule means this rule will come into implementation when there are a number of requests that will be triggered from that IP address. So we can give it a rate-based rule as well, but right now I'm defining it as a regular rule. Now we need to define that if a request matches this statement, what will be inspected in that request. So basically we can inspect that whether it contains HTML or cross-site scripting payloads within query parameter or all query parameter, or it contains those payloads within the URI path or the query string or body. We can select any of these request components that we need to validate and check for the cross-site scripting or HTML payloads. Let's select query string for now. Then we are going to match within the query string a regular expression pattern set. Let's click on it. Then we can select the pattern set that we have created, which is stop cross-site scripting and HTML attacks. Once we select it, we then need to define what action do we want to take on the request that matches this regular expression pattern. I want to block all those requests and then I will click on add rule. And you can see that our web ACL, which is first WAF ACL, has been successfully updated. And now we need to define the rule priority. Let's click on save for now. As you can see, the priority for this rule is 0. As we just have one rule, it is the first rule that will be evaluated for a new request. If you have multiple rules, you can define the appropriate priority for this rule and it will be evaluated based on this priority. So that's how you create regular expression pattern sets and use those regular expression patterns within access control list. I hope you have enjoyed this lecture. You have learned something new. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we are going to learn about CSPM, which is Cloud Security Posture Management. So let's see what is CSPM. Cloud security posture management is the process of identifying misconfigurations and compliance issues within cloud. So it means that whatever the configurations that a security engineer or a DevOps engineer might be setting up within the cloud infrastructure, there can be issues within those configurations. Similarly, we are bound to follow any compliance framework. It can be HIPAA, it can be PCI DSS. There can be issues while implementing those compliance frameworks. So tools like Aqua, which implements cloud security posture management, helps us to automatically identify such kind of misconfiguration and compliance issues within cloud environment. It can be any cloud environment, AWS, GCP, Oracle, or other cloud providers. So that's what a CSPM is. I hope you now understand what is CSPM. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to understand how Aqua implements cloud security posture management, and this is an example of AWS integration. So this is an architecture diagram provided by Aqua. If you see towards the right, Aqua Cloud Security Posture Management integrates with AWS using the Aqua CSPM IAM rule. So basically, when we will integrate Aqua with AWS, we will have to create an IAM rule using which Aqua will be able to read all the configurations within the AWS account. So in the coming lectures, we will do a hands-on demo where we will implement Aqua. For that, we will first integrate Aqua with AWS. We will have to create this IAM rule. Once we will create this IAM rule, Aqua will be able to read the entire configuration within our AWS infrastructure and provide recommendations. So I wanted to share this architecture diagram with you so that you can understand how Aqua integrates with AWS and then identifies issues within the AWS account. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to create a trial account for Aqua Security. I'll take you through all the steps required in order to create a trial account with Aqua. So let's start. So first we need to visit the sign up page. So I'll click on it and open it in a new tab. As you can see, this is the sign up page for Aqua, and also they require a business email address in order to sign up. So since I have the business email address, I was able to sign up here. But in case you do not have a business email address, I'll explain how you can create a business email address free of cost. So let's switch to Google. I'll search for Bugcrowd. Bugcrowd is a cybersecurity platform where organizations list out their web applications and other applications for freelancers or security researchers to identify security issues, and in return they are rewarded for identifying security issues. So let's click on Bugcrowd. Let's click on Researcher Portal. And since I have already registered, I'll just create a new account for this demo purpose. So now since we are on sign up page, we will have to enter few details. So let's enter those details. I'll enter my name, my last name, which is Guru. Then I'll enter my email ID. I will enter my other email ID since I'm already registered on Bugcrowd platform. And I will enter a strong password. And then I'll click on sign up button. Now it will ask us to confirm our email ID. I'll just switch to my email ID, and as you can see, we have received the email ID. I'll click on confirm my account, and it will take me to Bugcrowd again, and it will ask me to enter my password. Since I have saved my password, I'll just click on continue. So once we click on continue, then most important thing is it will ask me to enter a username. Now this is most important thing for us. We need to remember this username. So I'll give some other username since I've used a security guru username to create one account. So I'll give it as a security guru 10 and I'll click on continue. And then again I'll click on continue. we'll click on skip this step. Again, skip this step. And we have created our account successfully on Bugcrowd. Now, let's see whether we are able to use this email of Bugcrowd for signing up to Aqua. So now, let's see what was our username. We gave username as asecurity.guru10, and since we are registered on Bugcrowd platform, so we will type it as bugcrowdninja.com. I'll give a password. I'll accept the terms and then I'll click on sign up. And you will see that we are able to sign up. So that's how you can sign up on Aqua Security by getting a business email ID. So now, as you can see, the sign up is successful and they have sent an email for confirmation. So now let's go back to our email ID. So basically, when Aqua will send an email, it will first go to Bugcrowd and then it will be sent to our Outlook email. So let's wait for a few minutes. As you can see, we have received the email. It went to the junk email. So since the email has been forwarded to one domain and then to our Outlook domain, that's why it went to the junk email. So the email was sent by Aqua to bugcrowdninja.com and then it went to outlook.com. So that's why it was sent to junk email. So just check your junk email in case you are following this process. So now let's click on confirm email. Now, as you can see, it says that your account has been successfully confirmed. Let's click on sign in. It is signing us successfully. Let's wait for a few seconds. And as you can see that we have logged into Aqua dashboard successfully. We can see our trial account has started. We have 14 days left now. And in the next chapter now, we will connect our Aqua Security dashboard to our AWS cloud. So I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to learn about cloud security posture management. We are going to perform a hands-on on implementing cloud security using Aqua. So Aqua provides a functionality called CSPM, Cloud Security Posture Management, using which we can scan our entire cloud for any configuration issues that can result into security attacks later. So how can we avoid such kind of configuration issues? By connecting Aqua with our cloud platform. So let's see how we can connect our Aqua security tool with our AWS account. So first we need to click on connect cloud account. So now we have logged into CSPM module of Aqua and we can connect our account. Let's click on connect account and you can see that we can select the cloud account type. Since we are using AWS, I'll select it, select the connection method. I'll select it manual setup. I'll click on next. Now Aqua has given us some instructions to connect our Aqua security account with AWS. So let's see how we need to do it. For that, we need to enter two things in AWS. One is this account ID and second is the external ID. So let's first copy this account ID and let's switch to AWS dashboard. I have opened Identity and Access Management Service within AWS. Now let's click on roles and let's click on create role. Now we need to select AWS account. Here we need to select another AWS account. We need to select the account ID and we need to paste it here what we have copied from Aqua. Now we need to select require external ID. Let's click on this and it will ask us to enter an external ID. Let's go back to Aqua and copy this external ID and let's paste that external ID here. Let's click on next. Now we need to add a new policy to this role. As per Aqua, we need to add security audit managed policy. So let's copy this and let's paste it here. Hit enter. Select this security audit policy. Click on next. We need to provide a role name. I'll provide it as Aqua Security Demo, and I'll click on next and create role. As you can see, it has started creating role. Role has been created. Now let's view this role, and the role has been created. Now the most important thing is AWS resource name, which is called ARN. Let's copy it. Let's go back to Aqua and let's paste it here. Now let's try to test our connection. You will see that the connection has been successfully established. Now let's close this. As you can see, we have successfully connected our AWS account with Aqua. So in the next chapter, we are going to scan our entire AWS infrastructure using Aqua. Aqua will provide us recommendations on how to improve the security within our cloud infrastructure. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to run a Aqua scan on our AWS infrastructure to identify the configuration or the security issues. So let's start. I'll click on scan now, and it has given us that background scan successfully triggered, which can take up to 5 minutes to complete, after which the results will be available on the scan reports page. So let's wait for a few minutes, and then we will be able to see what Aqua has identified within our AWS infrastructure. I'll pause the video for now and then I'll connect back in few minutes. Hi everyone, welcome back. So now since the scan has been executed, let's click on scan reports. And as you can see that the scan has been executed and it has identified few issues. Let's click on it. And as you can see, that it has given us a score. So Aqua has given a score of B to our AWS infrastructure. There are some of the test cases which have failed, which are 427, and 3,927 test cases have been passed. You can also see that it has given us results by region, results by category or the various AWS services, and also it has given us the results by the plugin installed within our AWS infrastructure. So let's first click on plugin breakdown. So as you can see that it has given the number of issues identified for each plugin policy. So you can scroll down through all of these and then you can identify which plugin is vulnerable and which is not. Let's go to source breakdown category. You will see that it has given the number of issues for each resource category. It can be AWS project build, or it can be network ACL or the security group. It has tried to scan each and everything within AWS. Let's go to detailed result. Here it has also given us a functionality to filter our results. So we can filter our results. It can be fail or warning. Suppose if I am a security engineer, I just want to see the results which are fail. So let's click on filter. And I will be able to see that all these test cases have failed. And being a security engineer, my responsibility will be to go through all the failed test case and to identify the configuration issues and implement the required measures within our AWS. So that's how you identify configuration issues within AWS using Aqua. You can also export this report using CSV or PDF format, and you can present it to your stakeholders. So that's how you scan your infrastructure for any kind of security issues. This is the part of Cloud Security Posture Management Service provided by Aqua. I hope you have enjoyed this lecture. Thanks for watching. See you in the next chapter. Hello security gurus, welcome to this new lecture. In this lecture, we are going to install Terraform on a Windows machine. So let's jump into the action. I'm on google.com and I'm going to type download Terraform for Windows and I'll hit enter. As you can see, we are going to select the first link that we can see, which is downloads Terraform by HashiCorp. I will click on it. As you can see, we can download Terraform for Windows. For Windows, we have two options. Either we can download Windows for 32-bit, which is mentioned here as 386, or we can download it for AMD 64, which is for a 64-bit window. Let's click on AMD 64 because I'm using a 64-bit window. I'll click on it. As you can see, Terraform has started downloading. Let's wait for some time. Terraform download is complete. I'm going to open the zip file. I'll click on it. As you can see, Terraform zip file has been downloaded, and within that we can see a terraform.exe file, which is an executable file for Windows. Now I will copy this file. To copy this file, I'll select this file. I'll right click and select this option, copy files to clipboard. I'll click on it. Now our file has been copied. Let's create a folder on our local system. I'll go to my computer. I'll go to D drive. Within D drive, I'll open a Security Guru. Now here, I'll create a new folder. I'll name this folder as Terraform and I'll hit enter. I'll go within this folder. I'll now paste the executable that we have copied. As you can see, the executable file has been copied. Now let's set the path for this file. I'll copy this path. Now I'll right click on this PC. I'll go to properties. Let's click on advanced system settings. Let's click on environment variables. Now under system variables, I'll scroll down. I'll select path. I'll click on edit button. Now let's add a new entry for Terraform. I'll click on new button. Then I'll copy the path where our Terraform is present, which is D drive A Security Guru Terraform. I'll copy it. I'll click on new and I'll paste it here. Now our entry has been created. I'll put a backslash at the end and I'll click on OK. And then I'll click on OK and I'll close this option as well. Now let's open a command prompt to check whether we can run Terraform from any part of the Windows or not. In order to test that, I'll click on search. I'll type CMD. I'll hit enter. I'll zoom in and I'll type Terraform-H and hit enter. As you can see, Terraform has been successfully run from C drive users A Security Guru, which is a different location from the one where our Terraform is installed. Our Terraform was installed at D drive A Security Guru Terraform. So that's how you install Terraform and set the path variable for Terraform in order to run Terraform from any part of the Windows machine. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello Security Gurus, welcome to this new lecture. In this lecture, we are going to create an admin user within our AWS account. So let's jump into the action. I am on AWS console login page and I'm going to select a root user, which is asecguru@gmail.com, and I'm going to click next. Now I'm going to enter a password to log in into the AWS console. I'm going to click on sign in. As you can see, we are now on AWS console home. Let's click on IAM service, or you can also search for IAM here. If you type IAM in the search box, you will be able to see the IAM service on the top, which is Identity and Access Management. Let's click on it. Now one thing to notice here is that IAM is always global. It's not region specific. Now let's click on users. Now let's add a new user. I'll click on add users button. Now I'm going to provide a username. I'll give it as a security guru and I'm going to select the access key, programmatic access. So we are going to generate an access key for this user. Let's click on next button. Let's select the option attach existing policies directly. We are going to select a policy related to admin user. Now we have a search box where we can search for a policy name, but I am able to see the administrator access policy on the top. If you are not able to see it, you can search for the same using this search text box. Let's select the checkbox next to our administrator access policy and let's click on next button. We are not going to add any tags and I'm going to click on next button. Let's click on it. As you can see, our username that we are going to create is a security guru. We are going to have a programmatic access for this user and the policy that we have attached is administrator access policy. Let's click on create user button to create the user. And as you can see, user has been successfully created and you can see the access key ID and secret access key. If I click on show, you will be able to see the secret access key as well. In the next lecture, we are going to install AWS CLI on our local system and then we are going to use these access keys to log into AWS account using our command line interface and run any AWS commands for this user. So stay tuned. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we are going to install AWS CLI on our local Windows machine. So let's jump into the action. I'm on google.com and I'm going to type download AWS CLI for Windows and I'm going to hit enter. Now I'm going to open the first link that we are able to see here, which is installing or updating the latest version of the AWS CLI. Let's click on it. Now, if you scroll down, you will be able to see the AWS CLI installation instructions. There are different installation instructions for Linux, macOS and Windows. Since I'm working on Windows, I'm going to select this option and then you can see that in order to install or update the AWS CLI, we need to download an installer which is MSI format. Let's click on it. This will download an MSI file on our local system which is of 29 MB. As you can see, our AWS CLI version 2 MSI has been downloaded. Let's click on it to run the installer. As you can see, the setup has been started. Let's click on next button to install the AWS CLI. We're going to accept the license agreement and I'm going to click next. Let's select the default location for the installation and click on next. I'm going to click on install button. AWS command line interface version 2 is being installed on our local machine. Let's wait for a few seconds while it is being installed. As you can see, command line interface version 2 setup wizard has finished and let's click on finish button. Now let's open a command prompt here. I'll go to Windows search. I'll type cmd and I'll open a command prompt. Now I'll zoom in. Now I'll type a command AWS space configure. And you can see that AWS is asking us to provide an AWS access key ID. Now, in the last lecture, we created an admin user from the identity and access management within AWS console. Let's go to AWS console. Now, this is the user that we created in the previous lecture and we can see that there is an access key ID for this user and a secret access key as well. Let's copy the access key ID. I'll copy it. I'll open the command line again and I'll paste it here and hit enter. Now it is asking us to enter the AWS secret access key. I'm going to copy this again. I'm going to copy this. I'm going to paste it again here. Hit enter. Now it is asking us to select the default region name where we are going to mostly work. In my case, I'm going to select US West 2 because I'm going to create most of our services in US West 2. You can select any region you want where you would like to create your services. So I'll type US-West-2 and hit enter. It is also asking us what is the default output format that we expect. It can be a JSON format or any other format. I'm going to leave it blank for now and hit enter. And now we have successfully authenticated our local Windows machine with AWS. So if now we run any AWS command from our command prompt, that command will be executed within our AWS account. Now, for example, let's run an AWS command using which we are going to get our authentication details from our AWS console. So I'm going to paste a command here, which is AWS STS get caller identity. STS is secure token service of AWS, which is going to provide us a caller identity information. In this case, I'm going to hit enter. And as you can see that this is our AWS account information. This is the user ID for us, and you can see the ARN of our user. Now let's verify this information with our AWS console. On the right side, you can see that this is our A Security Guru user logged in within our AWS console. Let's click on it. And you can see that this is our account ID, which is 145988340565. This is a 12-digit AWS account ID. Let's compare it. And you can see that this is our account ID as well, which we got when we run this command. Now you can compare this ID with the account ID that is present here. Both are same. It means that we are able to run our AWS commands from our local system and get connected with the AWS console. So that's how you install AWS CLI on your local system and authenticate with your AWS account. Stay tuned. Thanks for watching. It's going to be really interesting. See you in the next lecture. Hello Security Gurus, welcome to this new lecture. In this lecture, we are going to learn how to install Visual Studio Code on Windows 10. Visual Studio Code is an integrated development environment free of cost from Microsoft. Using Visual Studio Code, we can edit, update or write new YAML files. So let's see how to install Visual Studio Code. I'm on google.com. I'll search for Visual Studio Code download. So this is the first link using which we will download Visual Studio Code. The link name is code.visualstudio.com. Let's click on it. As you can see, we can download Visual Studio Code for Windows, Linux and Mac. Let's click on Windows. As I am using Windows, I'm going to download it for 64-bit. If you are working on 32-bit, please download it according to your operating system. I have clicked on it. As you can see, it has started downloading. Let's wait for a few seconds. As you can see, Visual Studio Code has been successfully downloaded. Let's double click on it. Visual Studio Code installer has been opened. I'll accept the Microsoft agreement and I'll click on next. As you can see, it is being installed under users, then your username, app data, local, programs, and then Microsoft Visual Studio Code. I'm going to install it at a different location. I will click on browse. I'll select software. So I'm going to install it under D drive, software and Microsoft Visual Studio Code. We will require at least 292 MB of free disk space for installing this software. So let's click on next. As you can see, it is going to create a start menu folder for us. That's fine. Let's click on next. I'll create a desktop icon. It is going to add Visual Studio Code to our path variable as well. It is going to register code as an editor for supported file types. So let's click on next. Now the summary of the installation can be seen here. It is being installed under D drive, software, then start menu folder is being created and we are creating a desktop icon and we are also adding it to our path variable. Let's click on install. It is installing the Visual Studio Code now. Let's wait for a few seconds. As you can see, Visual Studio Code has been successfully installed on our local system. Let's click on finish and it will open Visual Studio Code. As you can see, Visual Studio Code has been successfully installed on our local system. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello Security Gurus, welcome to this new lecture. In this lecture, we are going to clone this repo on our local system. This repo will help us to create an infrastructure on AWS I have also included the README file within this repo, which contains the information as to how to run the Terraform using this repo, what are the steps that we need to follow in order to create our infrastructure, and then some important commands that we need to run from our local system in order to create this infrastructure. Also, I have written all the Terraform files like main.terraform, which is internally using install jenkins.shell script, which has the required commands to create the infrastructure to bring up an EC2 instance. On this EC2 instance, there will be Jenkins installed, and also we will install all the required infrastructure on this EC2 instance. We will go through all these files in the next lecture. Right now, in this lecture, we are going to clone this repo. If you want to fork this repo and bring a copy of this repo in your GitHub account, you can do so by clicking on this button. It is disabled for me because this is my own repo. Now let's clone this repo by clicking on code button and then selecting the HTTPS option. Let's copy this URL. I've copied this URL. Now let's open our location on our local system. I'll go to File Explorer. This is our File Explorer. I'll go to this PC. Then I'll go to D drive. Within D drive, I'll go within a Security Guru folder. Within this folder, I'll create a new folder. And I'm going to name this folder as Terraform AWS Infra Repo, and I'm going to hit enter. I'll open this folder, and within this I'll right click and click on git bash here. I'll zoom in. Then I'm going to type git space clone, and I'm going to paste the URL that we have copied of the repo. I'm going to clone it. As you can see, the repo has been cloned. Let's verify it on the local system. As you can see, the repo has been cloned, and within this repo, you can see all the files that we saw on GitHub as well. So now, since we have cloned this repo on our local system, in the next lecture, we're going to understand all the files that are present in this repo before we create our AWS infrastructure. So stay tuned. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to understand the structure of our Terraform repo that we have cloned in our previous lecture. Now for this demo, I have removed all the extra files that were present in the repo. Now we only have the required files in our repo, and also we are going to import this Terraform repo within Visual Studio Code, and then we are going to understand the structure of the repo. And once we have understood the structure of the repo, then we are going to understand the code that we have written within main.tf and related files in order to create the infrastructure within AWS using Terraform. So in order to understand the structure of this repo, I'm going to use Visual Studio Code, and I'm going to import this folder within Visual Studio Code. So let's jump into the action. I'll go to Windows Search and I will type Visual Studio, and you can see that Visual Studio Code is present here. I'll open it. As you can see, Visual Studio Code has been opened. Let's go to File. Let's go to Open Folder. Let's click on it. Now I'll go to this PC. Then I'll scroll down and I'll go to D drive. Within D drive, I'll go to a Security Guru, and I'll go to the folder where we cloned our repo, which was Terraform AWS Infra repo, and within that, this is the repo that we have cloned. Let's click on select folder. And now our Terraform repo has been successfully imported within Visual Studio Code. Now let's understand the structure of this repo. Within this repo, we have a vars folder which is used to keep all the variable files. As you can see, we are going to create our infrastructure within DevSecOps 2. So we have created a tf vars file within vars folder. Then install _ jenkins.shell script we have written in order to install software on EC2 instance that we are going to create using Terraform script. Main.terraform contains the entire script that we have written in order to create EC2 related security groups, a role that we need for EC2 instance, and other details. Output main.tf is used when we want to store the output of the infrastructure creation within a file, and then I've added a readme file just to help you understand how to run the Terraform commands and some useful commands that we will use in the upcoming lectures of this course. So in the next lecture, we are going to understand the script that we have written within main.tf. Main.tf is the primary file that is searched by Terraform in order to create the infrastructure. From main.tf, the other files like install_jenkins.sh is referred. So we will first understand main.tf and then we will go to the related files being referred by main.tf file. So I hope you are now familiar with the structure of the repo that we have created for Terraform. Thanks for watching. Stay tuned. It's going to be really interesting. See you in the next lecture. Hello security gurus. Welcome to this new lecture. In this lecture, we are going to understand the code that we have written within main.terraform file. So let's jump into the action. This is the main.terraform file which we have opened within Visual Studio Code. Main.terraform file contains the entire code that we have written for creating our infrastructure within AWS. Terraform provides a library called AWS using which we can create various services within AWS. If you want to see which all services are supported by Terraform, so let me switch to the browser, and this is the Terraform AWS provider where you can see all the services for which Terraform has provided the support. So you can select any service and you will be able to see the code written on the right for that service. For an example, if we search for EC2 instance here, once we search for EC2, we will be able to see EC2 service here, and if I select AWS AMI here, you will be able to see how to write the code for an EC2 AMI. If I select any other EC2 related component, for an example, a key pair that we need in order to connect to EC2 instance, so this will be the code that is required for writing the script within Terraform. So Terraform has provided all the script related support on their documentation website. I'll provide this documentation URL in the resources section of this lecture. You can refer to it. Now let's go back to Visual Studio Code and understand the code that we have written. We are using a required version of Terraform and we are using a provider AWS as we are going to create our infrastructure within AWS. Then we are creating an AWS security group here. As you can see, this is the AWS security group that we are creating. Within that, we have given an ingress security group details like the to port is 8081 and from port is also 8081. The reason is that because we are going to deploy our Jenkins on 8081 port. That's why we have allowed 8081 port within the security group that will be attached to EC2 instance. And also you can see that the CIDR block is 0000. It means that the security group is open and anybody can access this instance from the internet. Next is we have added SSH rule to the same security group that on port 22 we will be able to access the EC2 instance and anyone can access this instance using the 22 port. Then we have the egress details of the same security group and we have given a tag to it as well where we have given the name Jenkins SG. So this is the entire detail related to AWS security group. After that, if we scroll down, we will be able to see the AMI details where AMI stands for Amazon Machine Image. So for creating our EC2 instance, we are going to use Amazon Linux image. Then we are going to use the particular image detail which is HVM 2.0. We have given the virtualization type which is HVM. We are going to attach an elastic block storage which is EBS here. Then we are going to also create an AWS IAM role which I have given the name as test role. Now this test role we have created. This test role will be attached to EC2 instance so that EC2 instance is able to access our Kubernetes cluster. This role will have the admin permission here. As you can see, it has the full permission here. So it means that once this test role is assigned to our EC2 instance, EC2 instance will be able to access our Kubernetes cluster and any other service as well. So we will create a role here. We will provide full permission to that role, and then we will attach this role here as an instance profile to the EC2 instance. So you can see that we have created an instance profile. That instance profile will be attached to the EC2 instance. You can also see that we have provided full permission while we are creating an AWS IAM role policy as well. So that is the detail related to the role that we are going to create as an instance profile, and we are going to assign it to EC2 instance. After that, we are going to create our AWS instance, and we have provided details like Amazon machine image, Amazon machine images, the Amazon Linux image. The instance type we are going to use here is T2 extra large. The reason I am using this image is that I want to have a good performance with our Jenkins image, but this will be charged. If you are working on a free tier, you can use an T2 micro image as well. Then we need to provide a key name. So we will create a key as well before we can access our EC2 instance. Then we are attaching an IAM instance profile that we created above to our EC2 instance. Then we are also attaching the security group that we have created above to our EC2 instance. Then we are providing the user data. User data is an option where we can provide some commands to our EC2 instance after it is created. So we have provided a shell script which is install Jenkins shell script to our EC2 instance. So once our EC2 instance will be created, these commands will be run on that EC2 instance. We will go through install jenkins.sh as well in the next lecture. And finally, we are attaching a tag of name Jenkins to our EC2 instance. So when our EC2 instance will be created, we will be able to see that Jenkins is the name of that EC2 instance. We will verify this information on EC2 dashboard as well. So in the next lecture, let's now go through install Jenkins shell script. So see you in the next lecture. Thanks for watching. Hello security gurus, welcome to this new lecture. In this lecture, let's start understanding the install_jenkins.shell script that we have written so that we can install the required softwares on our EC2 instance that we are creating using Terraform. So I'm going to click on install_jenkins.sh script. Here you can see that it's a shell script and this is the syntax for writing the shell script. Then you can see that we are installing the updated packages on Linux machine. So since we are using an Amazon Linux, we need to use yum package manager to update the existing packages on the Linux machine. -y is used to say yes to any response that might come while installing the packages. After that, we are downloading the Jenkins on that Linux machine. After that, we are importing the RPM of Jenkins. Then we are using the yum upgrade command. Then we are installing OpenJDK 11 on EC2 instance. Then we are installing Git on the EC2 instance. After that, we are installing Maven on the EC2 instance. So these all commands are used to install Maven from line 12 to line 14. Once Maven is installed, we are installing the Jenkins. Once the Jenkins is installed, we are changing the Jenkins port to 8081. After that, we are reloading the daemon using systemctl command to detect any changes in the packages. Then we are starting the Jenkins service and we are checking the status of the Jenkins service. Once done, in line 20, we are installing the AWS CLI on EC2 instance as well. These lines help us from 20 to 23 to install AWS CLI on EC2 instance. Scrolling down, then we are installing Zap on EC2 instance as well. Then we are installing kubectl on the EC2 instance. So from line 29 to 32 will help us install kubectl on EC2 instance. We need kubectl in order to interact with Kubernetes cluster. Once done, in line 33, we are downloading a package named EKSCTL. EKSCTL help us to create an elastic Kubernetes cluster within AWS. So within AWS, the clusters are created using EKS service, which is also called Elastic Kubernetes Service, and we are using this utility EKS-CTL to create that Kubernetes cluster within AWS from command line. So we are installing this utility EKS-CTL on EC2 instance as well. So these two lines 33 and 34 will help us achieve that. After that, we are installing Docker in line 35. In line 36, we are adding our current user of EC2 instance to Docker group so that we can run the Docker commands without sudo. After that, we are refreshing the group. Same we are doing in line 38, where we are adding the Jenkins user to Docker group so that we can run Docker commands from Jenkins without the need of sudo as well. So here in line 39, we are refreshing the group again just to reflect the latest changes. Then we are restarting Jenkins as we have added Jenkins in Docker group. Similarly, we are reloading daemon as well to detect the changes made to the packages. Then we are starting Docker. We are enabling Docker service. We are checking the status of Docker service, and then we are installing a JQ library on the EC2 instance. These are all the softwares that we are installing on EC2 instance once our EC2 instance is created by our Terraform script. So in the next lecture, we are going to create our AWS infrastructure using Terraform. So stay tuned. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to understand about the variable file that we have added to our Terraform script, and also we are going to generate a key pair that we will need in order to create an EC2 instance using Terraform. So let's jump into the action. So first we will see what is the variable file under the vars folder that we have within our Terraform repo. So I'll expand this folder. Within that you see dev-vest2 tf vars file. I'll click on it. Now this file is used to store variables that we are using within our main.tf file. So as you can see, we have defined that AWS underscore region is equal to US West 2. So if we copy this AWS underscore region and we search within main.terraform, I'll search it and you will see that we are using the value of AWS region here. So ultimately the value of AWS region is defined here in dev-vest2 tf vars file. The value is US West 2. So we are going to create the EC2 instance within US West 2 region, and we have created this variable under this file. This variable is being referred in main.tf here itself. Similarly, if we go through the other variables like VPC underscore ID, CIDR block and key name, we are using VPC ID and key name within main.tf as well. I have removed CIDR block because we have kept our security groups open, hence I have not used CIDR block. But if you want to restrict the access to your EC2 instance and Jenkins installed on that instance, you can have a CIDR block according to the IP address range that you are using, and then you can use this variable in main.tf file. So that's the use of dev-vest2 file, and this file is passed to the Terraform script which we will run here. So here you can see that we will run Terraform apply and we will pass this variable file to the Terraform here. We will pass it as -variable -file equal to within vars folder we have this file which is dev-vest2 tf vars. So that's how we are going to use this file to create our infrastructure. But one important thing that we have defined within dev-vest2 tf vars file is key name. Now this key name helps Terraform to access that EC2 instance to install all the softwares on that EC2 instance. Now this key pair is generated from AWS dashboard. So let's switch to AWS dashboard now. I'll switch to AWS dashboard. Here I'll click on EC2 service. I'll click on it. Now we are on EC2 dashboard page. You can see that I'm using the new EC2 experience by clicking on this toggle button. You can click on it if you want to see the same UI. Also, one more thing to notice here is I'm already using US West 2 region here, which is US West. If you are able to see some other region, make sure that you use the same region within Terraform script that you are using here to create the key pair. Now, in order to create the key pair, I'll click on launch instance. Now here you will see all the information required in order to create an EC2 instance. If I scroll down, you will see there is a key pair option here for our login to our EC2 instance. We can also create a new key pair by clicking on this create new key pair button. Let's click on it. Let's provide a suitable key pair name. I'll provide it as a security guru key and I will copy it as well. Now it is asking us that whether we want to have key pair type of RSA. Yes, we want to have this RSA, so I will not change this option. Then it is asking that which private key file format we need, .pem or .ppk. We are going to select .ppk and then we are going to click on create key pair button. As you can see, our A Security Guru key pair has been successfully downloaded. Let's open the location where this file is downloaded. I'll click on show in folder. As you can see, this file is downloaded under downloads folder. I'll copy it. I will copy this. Then I'll go to D drive, A Security Guru. Then I'll go to our repo which we have cloned on our local system. Then I will paste the file here within our repo as well. Now this is the putty private key file that Terraform is going to use in order to access the EC2 instance. I'll copy the name of the file as well. I'll copy it. I'll go back to Visual Studio Code and I will update the key file name here as well. So as you can see, the key name I have provided a security guru key. I have not provided .ppk extension. It is not required. You just create a key pair from AWS and place it in the repo. As you can see on the left side, we can see a security guru key.ppk is present now in our repo. You just copy the name of the ppk file and place it here in tf-force file. And that's it. Now we are all set to create our infrastructure using Terraform. So stay tuned and see you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we are going to create our AWS infrastructure using the Terraform script that we have written. So let's jump into the action. The steps that we need to perform in order to create AWS infrastructure using Terraform are given in the readme file in the repo that I will be sharing in the resources section of this lecture. So please read the readme file and go through the steps that are required for running the Terraform to create our AWS infrastructure. Now let's perform this demo. In order to perform these commands, I'll go to terminal and I'll open a new terminal within Visual Studio Code. Visual Studio Code will now open a PowerShell at the location from which we have imported our Terraform repo within Visual Studio Code. So the location from which we have imported this repo is D drive, A Security Guru, Terraform AWS Infra repo, and within that we cloned our repo and we imported this repo within Visual Studio Code. So the first command that we are going to run is terraform init. Let's copy the terraform init command from the readme file and I will paste it here in PowerShell. Let's hit enter. As you can see, Terraform is initializing the backend and it is initializing the provider plugin, which in this case is HashiCorp AWS, because we are creating infrastructure within AWS. It is also downloading this AWS library and it will create a library within the current installation directory. As you can see, a new directory is available now. Within that, Terraform has downloaded the library that will be used to run AWS commands. As you can see, Terraform has created a log file as well, which is terraform log.html. This file is used to download always the same version of the library that we are currently using. This way, in the future, if we are going to run this script, it will still download the same old version instead of downloading the new version. This helps to keep the project stable. So for an example, if suppose there is a current version that we are using within this repo is 0.1.2 for a particular software, terraform log.html file will save that version of the software in this file, so that in the future if there is a new version of the software, it will not download the new version. It will still download the one that is declared within terraform log.html file. So this is done to make sure that project remains stable and does not break because of the new changes of the software. Now let's run the second command, which in this case is terraform plan. I'll copy this and I'll hit enter. Now, before hitting enter, we can also provide another option while running this command, which is -out command. -out option is used when we want to save the output of the Terraform plan command in another file so that we can use that output always instead of running plan command. So basically, if we run Terraform plan and use an out option, we can provide a file name which can be output.tf file. So what Terraform will do is, as soon as it will complete the Terraform plan command, it will put the output in output.tf file, and after that we can run terraform apply using the output.tf file. So this is another way where you save the configuration from plan in a file and then run that file. But just for the demonstration purpose, I will not provide any out argument. I will directly run the plan command, and let's see the output. I have hit enter, and now Terraform is checking the changes that are going to happen because of the script that we have written. As you can see, Terraform is printing a lot of information, and this entire information will be created by Terraform because of the script that we have written. As you can see, it is saying that AWS instance will be created. If I go above, it will tell us all the resources it is going to create. For an example, it is going to create a test profile. It is going to create an AWS instance. So once it will create, only then we will know the ARN of that resource. So it has mentioned that known after apply. So once we run the apply command, only then we will get to know this information. So let's run the apply command now. I will copy the last command in this readme file, and this is the step 2, and the last step that we need to run. I'll copy this command and I'll paste it here, and I'll hit enter. While Terraform is creating the resource, let's go to AWS console and EC2 dashboard. I am on AWS console. Here I'll go to EC2 dashboard just to make sure that currently there are no instances running. As you can see, currently there are no instances running. Let's go back to Visual Studio Code and let's wait for Terraform to finish the apply command. Let's wait for a few minutes. This is going to take some time. As you can see, it is reading the file. Now Terraform is asking us that all the above resources will be created. It is asking us whether we want to perform these actions or not, and we will have to provide a value yes. So I'll type the value yes here, and I'll hit enter again. So now Terraform will start creating all those resources within AWS. So let's wait for a few more seconds. As you can see, Terraform has started creating the test role, the security group, then it is creating the role policy, the instance profile, then security group, and then it is creating the AWS instance, and finally it will run the shell script on AWS instance to install all the softwares that we need in order to implement our DevSecOps pipeline using Terraform, Jenkins, and Kubernetes. As you can see, Terraform has completed all the changes here. The resources created are 5. Let's verify these resources on AWS instance. I'll go to AWS again. I'll refresh this page. Make sure that you are in the same region in which you are creating the Terraform resources. And as you can see, instance running is now 1. Security groups are now 6. If I click on instance running, then we will be able to see the instance that is currently running. You can see that we have given the Jenkins as the name to the EC2 instance that we are creating. So Jenkins instance is present. Instance ID you can verify. You can verify that instance state is running. You can verify instance type is T2 extra large. I have selected. You can select T2 micro as well. The availability zone is US West 2, and currently the status is initializing. It means it is still finishing commands to bring up the EC2 instance. Let's wait for a few seconds while AWS is finishing all the commands to bring that EC2 instance. If I click on the instance ID, we will see more information about this instance. It says that public IP DNS address. Now let's open this address in a new tab. As you can see, this address is open. And as you know that we installed Jenkins on 8081 port, and let's see the Jenkins homepage. I'll remove the HTTPS because there is no SSL certificate installed. It will be HTTP, and I have added a port 8081 and I'll hit enter. And you can see that Jenkins is coming up. So as you can see, Jenkins is successfully installed with the script. So it means that our script is successful and we have successfully created our EC2 instance with Jenkins and other software installed on that EC2 instance using Terraform. So that's how you run a Terraform script in order to create the infrastructure within AWS. So thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we are going to create Kubernetes cluster using EKSCTL utility that we installed on our EC2 instance. So let's jump into the action. I am on our EC2 dashboard and I am going to click on connect button to connect to our EC2 instance. So let's click on it. I'll scroll down and I'll click on connect button. As you can see, it has opened a new tab which is EC2 Instance Connect, and here our shell with the EC2 instance will be connected. Let's wait for a few seconds. As you can see, we can now access our EC2 instance. I'll zoom in. I have zoomed in so that you can see the commands that we are going to run. Now, as I mentioned during the initial lectures that all the important commands are present in our Terraform repo. So this is the Terraform repo, EC2 Jenkins, AWS Kubernetes infra creation, and if you scroll down, so I'll copy the command to create the EKS cluster. I'll copy it and I'll go back to our EC2 instance and I'll paste the command here and I'll hit enter. And as you can see that cluster creation has already started, and you can see that building cluster stack, the stack that we have given. Now this process will take at least 15 to 20 minutes before the cluster is created and we get our control back on this shell. So let's wait for a few minutes and then come back and verify if our cluster is created or not. I'll see you in some time. Hello friends, welcome back. As you can see, our Kubernetes cluster is about to get ready. And you can see that the stack deployment is getting completed. You can also see that we started around 9:29 or 9:30 and currently it's 9:43. So it is taking around 15 minutes to still bring up the cluster ready. Let's wait for a few more minutes. Hello friends, as you can see, our Kubernetes cluster is ready. You can see that the control plane availability was completed. Then the kube config was saved at this location. Now this is very important. Kube config file saves the entire configuration that is required in order to connect to our Kubernetes cluster. So this is very important. After that, you can see that the cluster has been created. Node group has been created, which has 2 nodes. You can see the node IPs as well. After that, you can see both the nodes are ready and kubectl command should work with this location. So basically this config has been loaded to kubectl to access the cluster. We can run kubectl get nodes command to see the details. As you can see, both the nodes are ready and we can see the details. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture, we are going to clean up the resources that we have created in the previous lectures. So first, we are going to delete the Kubernetes cluster that we created. So I'll copy this command to delete our Kubernetes cluster. This command is present in our Terraform repo that I'll be sharing in the resources section. Let's go back to our EC2 Instance Connect and let's paste this command here and hit enter. You can see that our Kubernetes cluster is being deleted. It will take few minutes, like 5 to 10 minutes, in order to clean up all the resources related to this Kubernetes cluster. So let's wait for a few minutes. While our Kubernetes cluster is being deleted, make sure that you first delete the Kubernetes cluster using this EC2 instance. Only then you run the Terraform destroy command to destroy the EC2 instance. as you can see, the stack related to Kubernetes cluster is being deleted. It is waiting for stack to get deleted. It is waiting for Linux nodes as well to get deleted. Let's wait for a few minutes. Hello security gurus, welcome back. As you can see, all cluster resources were deleted. It took around 9 minutes to clean up the resources. It can take around 10 to 15 minutes to clean up the resources. Now since we have deleted the cluster, let's also delete the EC2 instance. For that I'll go to Visual Studio Code and I'll type this command terraform destroy. Instead of terraform apply, we will use terraform destroy command. So terraform destroy command will also be present in the readme file of the terraform repo that I'll be sharing in the resources section. Let's hit enter. Now we have run terraform destroy command to destroy all the terraform resources that we created. Let's wait for a few minutes while terraform is cleaning up all the resources. As you can see, to clean up all the resources, we have run terraform destroy command, and you can see that terraform is currently reading the resources that it destroy, and it will ask us again whether we want to destroy these resources or not. I'll enter yes and I'll hit enter. Yes, we want to destroy all the resources and our managed infrastructure, and you can see that it is destroying all the resources one by one. And Terraform destruction takes very few seconds. It will be done in under 1 minute. Let's wait for a few seconds. And as you can see that Terraform has completely destroyed all the resources that we created using Terraform. So that's how you clean up all the resources that we created in this course. I hope you have enjoyed this lecture. Thanks for watching. See you in the next lecture. Hello security gurus, welcome to this new lecture. In this lecture we are going to see infrastructure as code security demo using Bridge Crew tool. Bridge Crew is also software as a service application that scans infrastructure as code for security vulnerabilities. Bridge Crew is from Prisma Cloud, which is a product of Palo Alto Networks. So let's jump into the action and see the demo. I'll switch to a new Chrome window. I'm on google.com. I'll type Bridge Crew IAC scanning and I'll hit enter. Now I will open the first link, automated IAC security scanning and code fixes from Bridge Crew. I'll click on it. Now here, as you can see, this is related to IAC security and we can secure our infrastructure. Now IAC frameworks like Terraform, CloudFormation, and Kubernetes, these are all supported by Bridge Crew and can be scanned for IAC security misconfigurations. So let's create an account with Bridge Crew. I'll click on sign up button. Now there are few options to sign up with Bridge Crew. We can use our Google account, we can use GitHub account, we can use Bitbucket or GitLab account. Since I already have a Google account, I'll click on Google. I'll type my email. I'll type my password. Now Bridge Crew will ask us to provide an organization name. I will provide it as Raghu, the security expert, and I will click on save button. And you can see that we have successfully signed up with Bridge Crew. Now next step is to connect our code which we want to scan for IAC security vulnerabilities. I have a Terraform repo which is hosted in GitHub. Let's use that repo to scan for security vulnerabilities related to IAC. So I will click on GitHub to connect to that repo. I'll click on authorize button to authorize this account with our GitHub account. I will enter the A Security Guru username and password for that GitHub account. I'll click on sign in. Now I will select only the Terraform repo. So I'll select this option, only select repositories. I'll select the repository from the drop down. I'll type Terraform and this is the repo Terraform EC2 Jenkins AWS Kubernetes Infra Creation. I'll select this repo. I'll share this repo detail in the resources section of this lecture. You can clone this repo and then also test this repo for infrastructure as code security scanning. Let's click on install and authorize button. Now, as you can see, Bridge Crew has been successfully connected with GitHub. We will permit all the existing repo as we have just selected one repo for IAC scanning. I'll click on next button and we are done. I'll click on done button and our GitHub repo has been connected with Bridge Crew. You can see that now it is written as installed for GitHub. For others, it is written as not installed. I'll zoom in so that you can see it better. You can see Bridge Crew is successfully connected with GitHub. Now, in order to see the security vulnerabilities, let's go to dashboard. And you can see that Bridge Crew has already started reviewing the GitHub repo for IAC security vulnerabilities. It has identified two critical severity vulnerabilities, one high, two medium, five low. This is the repo that we have connected and you can see the repo name here as well. So the account in this case is a security guru which has been scanned and the repo within that account that has been scanned is Terraform EC2 Jenkins. This is the repo that we have used in our other DevSecOps course for infrastructure creation. Now let's see what are the issues that have been identified by Bridge Crew. So you can see some of the details here related to the vulnerabilities. Let's click on all the details by clicking on this Terraform link. I'll click on it. And you can see that Bridge Crew has said that ensure EBS volumes have encrypted launch configurations. If I click on it, you can see that the benchmark that Bridge Crew is following is PCI DSS version 3.2, and as per this benchmark, all the EBS volumes attached to EC2 instance should be encrypted. But since this was a test infrastructure that we were creating, we have not encrypted our EBS volumes. So as per this benchmark, they have recommended to encrypt our EBS volumes. Similarly, if I go to the next point, there it says that ensure every security group rule has a description. This is as per the benchmark SOC 2 and ISO 27001. ISO 27001, as you know, is used for compliance, and as per this benchmark, security group does not have a description. Similarly, you can see the other security misconfigurations that have been identified by Bridge Crew. IAC security is used to identify the security misconfigurations within the code that has been written for creating the infrastructure. Because of these security misconfigurations, security vulnerabilities are introduced in the infrastructure. So we need to understand the difference between these two terms. Now let's see a better view from where we can see the code as well related to these security misconfigurations. So I'll go to code projects and you can see the code now as well, that this is the code of EC2 instance where we were creating an EC2 instance using Terraform. And here this security misconfiguration has been highlighted, that EBS volumes that are being attached to the EC2 instance are being launched without any kind of encryption. Similarly, if I close this, you will be able to see all the 22 issues that have been highlighted. Let me click on the errors on the left, and if I scroll down, you will be able to see all the security misconfigurations one by one. As per the standard, Bridge Crew recommends that IAM policy should not allow full admin privileges. We are providing full admin privileges by using an asterisk here. But since this was a test infrastructure, we provided full authorization. But as per the recommendation, only the required permissions should be provided and not the entire admin access. So that's how you can identify security misconfigurations in your IAC code. The main goal of this demonstration was just to show you how you can use Bridge Crew and similar tool to identify security misconfigurations in your IAC code. That IAC code could have been written in Terraform or CloudFormation or any other framework, but we just wanted to present how you can do an IAC security scan. So I hope you have learned something new today and you understood how We identify security misconfigurations using ISE security tools. One such example of this tool is Bridge Crew. So I hope you have enjoyed this lecture. Stay tuned. It's going to be really interesting in the upcoming lectures as well. Thanks for watching. See you in the next lecture. Hello security gurus. Welcome to this new lecture. In this lecture, we are going to see the various areas within information security where we can build our career. There are various areas within information security that we can choose as per our experience level, expertise, and interest. So let's jump into the action and see those areas. The first area that I would like to present within information security is DevSecOps. This is a very promising area, very popular these days, and it's a highly demanding area because the amount of experience that is required to become a DevSecOps engineer is more, as we need knowledge of multiple tools in order to become a DevSecOps engineer. This includes creating build pipelines on cloud and on-premise tools. For an example, Jenkins pipelines, AWS pipelines, GCP, GitLab, build pipelines. All these pipelines are the responsibility of DevSecOps engineers. DevSecOps engineer needs to also take care of integrating security tools within these build pipelines. Those security tools can be Fortify, Veracode, SonarQube, and many other commercial tools. The next area which I would like to highlight is cloud penetration testing. This is similar to penetration testing, only difference is that the testing happens on the cloud environment and for the cloud services. So all the infrastructure within the cloud, the APIs or the microservices that are deployed within the cloud are tested by the penetration tester. Very promising area and specifically good for those security engineers who are looking to move into the penetration testing into the cloud. The next area which is also becoming very popular these days is container security. If you are interested in securing Docker containers, Kubernetes, and other virtualization applications, you can move into this career. Some DevSecOps engineers are also learning container security in order to build expertise in multiple areas. The next area which is also very promising and requires expertise is security architecture and design. This is the area where security engineer performs threat modeling, creates security checklist, and performs the architecture review of an existing architecture of an application or an application which is being built from scratch. Very popular area. The next one is web application penetration testing. This is the traditional method where the penetration tester performs the web penetration testing using tools like Burp or Zap. Very good area. There are a number of jobs in web penetration testing. The next one is mobile penetration testing, where the penetration testing happens for the mobile applications. Mobile applications can be hybrid or the native mobile application. So another interesting area. The last one which I would like to highlight is cloud security and compliance. This is actually a new area which has came into existence when the cloud became popular. The security engineer has the responsibility of implementing cloud security as well as take care of the compliance or the standards based on the region where the cloud data is stored. For an example, it can be a GDPR compliance which needs to be implemented. So these are the most prominent information security areas that I wanted to highlight. I hope you will choose the one that you have interest in and you will build your career into it. Please let me know in case you have any question and I will be more than happy to answer. I hope you enjoyed this lecture. Thanks for watching. See you in the next lecture.